Lakshmi, whenever you're ready, can you go ahead and make me the host or the co-host, please?
Sure, Sai. I'll just rename it. So must out.
Okay. Good morning, guys. Can everybody hear me? Could you give me a quick yes, please? Great. Thank you, guys. Hope you guys had a good weekend and hope you guys had a safe weekend. So let me see, bring this up. Great. And give me one moment here. Okay. And give me one moment, please, one more time. Sorry about that. This one. Okay. So sharing screen one more time. I'm just share this one. Okay. And let me bring this up. So let's see who all are here. Okay. So Amulya, Suresh, can you hear me, guys? Lavanya, can you hear me? Could you please one more time give me a yes, please? I want to make sure. So I'm checking. Okay, great. Thank you. Now I hope you can see. I only shared the pig screen, Apache pig screen. Are you able to see the slideshow here? I have it in full screen. Okay. I also want to make sure. Let me see. Let me go to the web shell here, and I think this is the web shell. Bring this down. Azure Lab subscription details. Now I have the web shell, the only agenda pages. Okay, that's what I'm trying to make sure. Okay, so a moment, I'll go back there. Let me come back to the pig and things like that. Okay, Lakshmi, are we having the assessment? Are we doing the assessment today, or are you there, Lakshmi? Oh, maybe Lakshmi signed off. Okay, sorry about that. It's okay, not a problem. And give me one moment while I make. I'm just checking something here, guys. Just give me one moment. Sorry about that. Okay, guys, sorry about that. Let's see. Now you're able to see the what is pig page, right, Suresh? Okay, great. Thank you, Revati. So let's get started, guys. How many of you got a chance to go over some of the Hadoop commands and the Hive commands, guys? Anybody did a little bit of practice and things like that? Can you give me a quick yes if you have done? Okay. If time permits, today try to practice a little bit. This week we are going to be reviewing Hadoop and Hive. Yeah, even if it is only a few commands, that's good enough. I need you guys to be familiar. Good, Niharika. And let's see what is pig. Pig is similar to what is Hive. If Hive is one of the eyes of Hadoop, then pig is another hive of Hadoop. Hive takes SQL-like commands as input, converts them to Java MapReduce programs, and in other words, it takes SQL as input and converts them into Java MapReduce programs, whereas pig is something which will take English-like statements as input and internally convert them into Java MapReduce programs, guys. That's what we'll try to look and understand today. So at a high level, just like Hive, pig is an alternative abstraction on top of MapReduce framework. Let me bring up my tool here. Oops, I think I need to share my entire screen. So let me stop the share. Okay. Move this a little bit up. Snap it. Put this here. Pardon me. Okay. So again, just like Hive, pig is an alternative abstraction. What do we mean by abstraction, guys? Abstraction is something which is hiding some complex things at a slightly low level. Anything you want to read, write, process, analyze is done through MapReduce. But the problem with Java, with MapReduce is you need to be an expert in Java, you need to be an expert in MapReduce. You need to think everything in terms of map and reduce, and that is tough, that is complex, guys, okay? So that is where Hive and pig come to our rescue. While Hive takes SQL as input, pig is taking English-like statements as input. Okay. It uses a data flow language called as pig Latin. In other words, the language of pig is not just referred as pig, but it is called as pig Latin. There is its own story and history of pig Latin, why it is called pig and things like that. At a slightly high level, they say pig will eat anything. And what they meant to say by pig Latin is pig can do anything. Anything and everything in the world of big data was a challenge and things like that. Or in other words, that is what they were trying to convey to the world, guys. So they named it as pig. Pig usually runs on the client machine and turns pig Latin script to MapReduce jobs. In other words, the script that we are going to be writing is going to be converted into Java MapReduce programs just like Hive. That is something important to be kept in mind. It runs on the client machine. Let's try to understand that. So imagine this is our laptop. And generally what happens is, if you recall, Hadoop is nothing but a group of computers. They're acting like a single machine. So put this here. And now, generally what happens, guys? Pig is the software which is generally installed on your laptop. When we run the pig scripts, what happens is, the scripts generate Java MapReduce program and the code is moving to the server. So the servers don't need the pig to be installed there. The person who's using Apache pig, that is where we need to install the pig. And what is it? That is generally referred as the client machine. In real world, generally all the servers and things like that, the administrators will generally go ahead and install it just in case for debugging and purposes like that is what really happens. MapReduce jobs will be submitted on the cluster. So in other words, again, the pig is generating the Java MapReduce programs and they are getting submitted, means the code is moving to the place where the data is and they're getting executed, they're bringing back the results. Everybody with me, guys? Quick yes, please. Okay. Go to the next one.
Sir, repeat last point once.
Yeah, I'll be saying that. Just stay with me. So again, writing MapReduce in Java is too low level. Again, pig and hive are supposed to be very, very high level. The last point is just the pig is converting the English-like commands into Java MapReduce programs, as simple as that, Niharika. So again, Java is very low level. We have to write what we will write. In 50 to 60 lines of Java MapReduce programs, we can write it with 1 or 2 lines of pig and hive. And MapReduce can be written in other languages, but they still need expertise. And in other words, thinking in terms of MapReduce is complex. And in the world of big data, we come across many, many complex scenarios. And it will not be possible for us to convert and think everything in terms of MapReduce. It is lengthier and it is very unproductive also, guys, okay? MapReduce framework requires a programmer. So in other words, we always need a Java programmer and an advanced Java programmer. And he needs to think in terms of MapReduce. Somebody who's good at Java, we always need to convert every problem into MapReduce. It's like trying to use a hammer for everything. Sometimes we need to use a screwdriver. If you think where you need to use a screwdriver, you cannot use a hammer. And if you need to think in terms of hammer, that is not productive, that is not right. And that is what is the problem with MapReduce. Understand the problem they are trying to solve. So any problem needs to be converted into MapReduce thinking. Enough time, they are generally time consuming, they're very unproductive in certain scenarios to think like that. Who will be available to maintain? So we need a programmer who will maintain the code. Any small change, you need to touch the code. Anytime the code is touched, a lot of testing, a lot of other things, budget and things come into the picture, guys, okay? All organizations do not have the above skill sets. In other words, today the companies are working with the data. What they need is, they don't need another IT organization or an IT department. They want their business people, they want the less skilled people to be able to work with data. They don't want them to learn IT. They don't want to go to IT because IT is a black box and it's a complex process in IT and things like that. And they cannot afford them sometimes and things like that. For examples, some companies may want their business analysts to be looking at the data. Data scientists, again, that is where all the money is today. These are the guys who are the hot and the latest and the greatest, where they are making a lot of money and they're trying to find a lot of insights in the data. They are not into the Javas or the .NET, but that's where a lot of Python is being used, guys, at a slightly high level. It requires high level abstraction on top of MapReduce. So again, when you go to the low level, slightly low level languages like Java and .NET, MapReduce comes into the picture and it creates its own problems, guys, okay? So Pig and Hive address these needs, and that's what we'll try to understand, guys, okay? Moving a little ahead. So Pig is referred as a declarative programming language. We'll try to understand. It is like, SQL is referred as a declarative programming language, which is nothing but SQL. The way we write the SQL, select, star, and things like that is nothing but declarative way of writing is what we say. Pig is referred as a data flow language. The reason it is referred as a data flow is we try to focus more on the data rather than the other programming aspects of it. So it is referred as a data. You focus on the data and you try to focus on the flow. It is slightly similar to SQL, guys. Okay, in other words, it is similar to SQL, but more precisely, the syntax is different here. And now here comes a slightly advanced one, slightly deep one. Schema is required in SQL. In a purely SQL world, schema is required. What that means is, imagine you have a database, and let's say we want to store some data into this database. So let's say here is some data. You want to store it into the database. What do? Well, what you need is, you need to create a table. You need to know the data types, you need to know the column names, the relationships, constraints, and things like that. In other words, what is all that? That is what is schema. Yeah. So schema is you first create a schema, then only you can say the data into the database in a purely SQL world. Pardon me. Okay, now schema at runtime and optional. So in the world of big data, generally what happens is, so well, let's say, come here. The world of, let's get rid of this. In the world of big data, in the world of Hadoop more precisely, what happens is, this schema is not required. Many times what we do is, we get the data. Let's say, we'll say this is the data. We directly save it in the Hadoop. That data can be structured data, that can be unstructured or semi-structured data. Then at a later time, what we want to do is, later we will go ahead and create the schema based on the data. And what is the meaning of that? That's what we'll try to understand. Okay, so in the world of SQL, in a purely database world, you first have the schema, you put the data on top of it. Okay, so in other words, if you don't have the schema, you cannot save the data. Whereas here, you first put the data, then based on the data, we create different kinds of schemas. So schema is created at runtime, and it is not a mandatory, it's optional. This is a slightly deep one. We'll try to understand when we are actually running it. Low latency queries. The world of database is the world of small data. It is not small data compared to the world of big data. The world of database is very small data. So what happens is, anytime you run a query, the latency is low, means that the delay is low. You will get even if it's 100,000, 10,000 or 100,000 records, you'll get it in the matter of a second or maybe 2 seconds. The database will return the data. That is low latency. Low latency means low delay. Whereas in the world of big data, we are generally dealing with terabytes and terabytes of data, multiple terabytes and petabytes of data. Okay, what is the problem here? Well, it is low latency is desired, but it is not mandatory. Here, when you run a script, what is happening is the script is getting converted to Java, MapReduce, and things like that. It is running on 10, 100, or 1000 servers. So if it takes a few seconds to a few minutes, and sometimes a few jobs will take a few hours, that is acceptable. Okay, so in other words, let me give you an example, guys. Okay, database, what kind of data you save is, imagine you have cricket data. Let's say you're taking the top 11 cricketers of the world, or maybe India, you're creating an application. You want to save their information in your application. That is the kind of information you save it. You're saving Sachin Tendulkar, you're saving Dhoni, you save it. Maybe tomorrow you will retrieve that information, you'll modify it, you'll delete it. You may add what is this one? These are called CRUD operations. In the world of big data, what do? Well, you don't do this kind of things. The data is already there. What will happen is, imagine Hyderabad Sunrisers. They want the top 11 players, and let's say Sachin Tendulkar was a top player. He suddenly moved on to Mumbai Indians. Now, what will happen in the world of big data is, the Hyderabad Sunrisers wants a replacement for Sachin Tendulkar. So they want to find somebody who's as close, whose characteristics are as close as possible to Sachin Tendulkar. And what do? Well, they can use their experience and say, maybe Dhoni, maybe Virat is a better replacement. But what is that? That is making the decisions based on your experience, based on a person. Imagine, let's say Suresh. Suresh is the coach of Hyderabad Sunrisers, and he's a big fan of Virat. And what do? Well, we are looking for a replacement for Sachin, but let's say Suresh chooses Virat. But better than Virat is Dhoni, let us say, for the sake of movement. So what is this? This is called bias or a partial. Suresh is being partial or is being biased because he's a friend of Virat. He's trying to lean towards Virat and make it. So what do? In businesses, that is what is the problem. What are businesses doing? Businesses don't want to make a decision just like that, based on somebody's experience, because they can be partial, they can be biased. What they want to do is they want to make a decision based on the data. That's where they will come to the data. Now, what will happen in the world of data? Imagine Hyderabad Sunrisers as a data team. What will they do? The data analytics team will take the last 100 or maybe 200 cricket matches of data. What are they doing? They're going to the internet. They're downloading from different websites. What are the different scores, different kinds of other information related to different kinds of players. And now what will happen? A lot of unstructured data they're gathering. What is that? They are first saving the data. They first save the data. Then what do? Then they will analyze the data using the schema. Okay, so what is that? That is no. So in other words, what they are doing is batch processing. This is an example of batch processing. The world of big data is more precisely an example of batch processing. No random reads. You don't get one record. What you're generally doing is you're looking at hundreds and thousands and millions of records. You're analyzing, you're processing and analyzing these records, and you're trying to perform different kinds of aggregations. And then you're trying to, again, use machine learning, all those things, and then return the data. So no random reads means, random read means, well, there is Sachin Tendulkar. What is his score in 19, or let's say in 2000, or let's say wherever we are in 2022. In 2018, what was Sachin's score against, let's say, West Indies or maybe Pakistan? What is that? That's a read. You go to the database, you give that information, it will give you a single row. That is the kind of information that you generally do in an SQL world. In the world of big data, tomorrow there's a cricket match with maybe West Indies or Pakistan. Let's say they are tough teams, maybe England. What do? Well, we want to predict if India is going to win or not. What do? That is batch processing. They will take the last 100, 200 cricket matches of data. They will try to process and analyze the data. That is what is an example of batch processing. That is what the big data is meant for. And today, every business wants to do that kind of analysis or analytics, guys. Okay, everybody with me? Quick yes, please. Okay, so this is how we get into Pig, and we'll see there is something called a local mode and a grunt shell. There's also something called an embedded mode, but looks like we're already getting in there. Okay, so let's see, in Pig also there are different kinds of data types, but a little bit of different terminology. Back to our basics, the integers, strings, and all those things are common. Integer, long float, the tea, green tea, ginger tea, and string is called a character array. Instead of string, they call character array. That's our coffee cup. Byte array is nothing for unstructured data, image data, video data, audio data is what it is. And we have a few complex data types called atoms, tuples, and bags. So these are like JSON objects, dictionaries and dictionaries of dictionaries, tuples, and things like tuple. We are all familiar. Bags and atoms we'll try to understand. Individual data types are referred as the atoms here, guys. Okay. So let's say it looks like we're getting into a little bit of action here. Let me see if I can access the web shell. And I'm going to go back, stop the share for one moment again. Let me check if the dashboard is up. I was having some issue with the dashboard today morning, guys, so I'm just checking. Azure console lab is not up. Okay. So I go back to dashboard and share the screen. Say share it and say where is Azure console? Here we go. Okay. Okay, guys, I'm going to go into the view lab. Click on view lab. If you're with me, if you're doing these things, I close this one. And I'll close. Okay, looks like I'm already logged in here. Okay, let me try this one. closed. One more time. Oops. Oh, sorry. Say connect. Big user. Oh, sorry. Big data. User one. YouTube. Right. Oops. Isn't it now? One more time. Let me pause the screen here. Check my. So 15. Big data is one. Okay. What's happening here? Big user one. Sorry. There you go. It's big user one. Resume the share. And what is it? Have they changed it or was like that? Okay, big user one. There you go, guys. Okay. So let's say what we'll do. The first thing is back to here. I'm in a map reduce mode. I think I just shared my screen of the web shell. Are you seeing my slide window, guys? No? You're able to see, okay. Okay, so let's say what we'll do, come back here. We'll get into the map reduce mode. I mean, first get into map reduce mode. And let's say pick. Okay, notice now it is connecting and this is where our name node is and things like that. And it's called a grunt shell. The grunt shell is what, just like Hive, we have Hive shell where we write the SQL commands. Here it is called only web shell is visible. Okay. How about now, Niharika? Are you seeing my slide now?
Sir, PPT slides are not visible, sir. Web shell is visible.
Thank you, Niharika. Okay, not a problem. So there is a grunt. I think pig will grunt. I think that's why they called it as a grunt shell is what it is, guys. Okay. But let's say I come back here, track tool in a grunt shell, load statement. So what I'll do is I will stop the share one more time. I'll share everything. Let's do a share, everything. And let's see what we have. Pick statements, so load statement, dump statement, and things like that. This is how it looks like. Oh, one more time, I'm going to pause it. I need to go back to my plus, see where this file is, say recent files, and let's see where it is. Okay, one moment. Commands. These are the group commands. Select star. Okay. Save this one. What else am I looking for? Just bringing up my pick commands, guys. One moment, please. Set time. Just welcome. Here we go. Spark. Labs. Let's pick. Okay, try this one. Okay, guys, I'm going to save this. Some TM. Sharing the screen again. And Niharika, I shared everything. Hope you're able to see the screen. The Edit Plus.
Yes, sir.
Thank you. Back here. Okay, so let's see. We'll start with some basic here. So here we go. We'll first see exclamation. What is this one? No, we'll just do an ls. ls is giving us notice. ls is giving. We're in a map reduce mode, and this is giving name service one user big user one. Now this is going to be a slightly tough one, guys. Okay, let me see if I can simplify it. Back here. So snap this. Okay, so back to couple of servers. Let me put a couple of Linux servers here. If you recall, here's Hadoop. Here's HDFS to be more precise. It's our virtual layer, virtual desktop. And now, if you recall, these were some of the files we loaded. From where did we load? Well, there was a file demographic data. Here we copied it and we pasted it onto the HDFS. Behind the scenes, remember, it looks like that file is there, but really that is getting split, that is getting distributed, that is getting replicated in the form of various blocks is what it is. So these are all the files like that, guys, and some of them are directories. Notice this one, name service one. What is this one? This is ideally the IP address or the machine name. So here they have given the machine name, and that is what, whether you'll give a, whatever is the name or the IP address is configured in a core site.xml is what we have done. Now, when you say ls, ideally, what happens, guys? It should give us a list of files in your ground floor, which is the Linux computer. But here, when we are logged into PIC, it is giving us a list of files here. And what is happening? Notice it is looking under the directory big user one because I'm logged in as big user one. So when we get into PIC, let's say scroll up here, what did I do? Let's say come here, choose this one. Now slightly deep on here, let's choose this one. I have entered PIC. This is called map reduce mode. We can also get into PIC in this mode, PIC -x local. If you get into the mode, if you get into the PIC using PIC -x local, that is called local mode. This is called map reduce mode. So let's choose this. This is called map reduce mode. And this is called local mode. In local mode, if you get in and if you do an ls, it will give you a list of files in the ground floor, not the first floor. So right now, by default, it is looking under user and big user one. If you remember what is called absolute path versus a relative path. So now what PIC is doing is it is working with Hadoop and saying, hey, look under user big user one, that is called relative path. Under this user, whatever all the files which are here, it's displaying. So one thing to note or remember is the straight Linux commands are working in PIC. ls will work. Then let's say come back here, back to the shell. Let's say cat or let's say tail. Grunt means it is the name of the shell, just like hype SQL. I think a pig will grunt, that's why they named it as that one. So let's say demographic data, demographic data.csv. Maybe it's not taking tail, but let's say cat. There you go. Cat is working. Let's say, oops, clear this one. Say, bring this up. Instead of cat, let's say head. Head and tail are not working, but cat is working. Clear. We can say cat. And then we clear it. Okay. So now what I'm trying to explain is what is LS doing because I got into. Now what we'll do is back to credential. I'm going to exit it. Now say quit. We're out. We're back to the dollar prompt. Dollar prompt is your default Linux prompt. Let's do a clear. Now take a look at this. One more time. We'll say pig -x local. Oh. Okay, one more time, pig -x local. Let's see if it allows. Good. Now we'll say ls. Now notice what it is giving. It is not giving, which is under the map reduce. It is not by default reading under what is under Hadoop, but it is now giving a list of files, all the files, whether they are hidden and other kinds of files, which are under big user one. This is under home. Okay, so in other words, in order to get into pig, you can enter in a local mode, or you can also get into a map reduce mode, is what is the meaning of that. Okay, so once you get into those things, okay, so now what we'll do, we'll say one more time, no, we don't need to quit. What we'll do is, these are all the files. Let's say cat user name .csv. So we have username, we have an identifier, the first name and the last name is what we have. And then let's say Hadoop fs hyphen, not put, but ls, and see if we have, so it's not taking the Hadoop command. Okay, so let's quit it. Let's say Hadoop fs hyphen ls. Let's see if we have already put users and username is there, cat users.csv. There it is. Not only in there, we also have it in our local machine. So now we have username, identifier, and first name. So let's say pig -x, get into local mode. Okay. So pig Latin statements are organized as load and dump. So the way we need to load the data, if you remember the world of Hive, we create a table, then we say load data local. In pig, you need to say A equals to load student, and that is going to be using pig storage. Okay, so what is student? Student is going to be the name of the file. We have to say using pig storage. Name is the name of the column, character array is the data type. So we are kind of giving the schema here. That is called the schema. Okay, now let's say if we come back here, we have users.csv. Let me come back here. So we'll say cat. Okay, we got into that one. Okay, let's say records, and what we'll do is maybe I'll keep it simple. One more time, I'll quit out of it. We'll create this file a.txt, a.txt. We'll put this data, some data like escape, say A, apple. Let's do a tab. I will say this is 1. Then D for dog, do a tab, and let's say 4. Next one is C for cat. And this one is 9. Okay, then we have K for kite. Pig -6 local means local mode. If you just say pig, that is called map reduce mode. And how much should we give? You can give any number. Let's say we give a 6. Now we're going to write and quit, get rid of it. You say ls-ltr. Notice a.txt is a local file. It is there in the ground floor. Now what we'll do, get into pig -x local cat a.txt one more time. So there is apple, dog, cat, and kite. Now what we'll do, we'll say records equal to load. So for us, what we'll do is, we don't need to give this one. A.txt is the name of the file. The first one is a letter. We're going to call that as letter. More precisely, it's a word. Okay, and character remains string. So it's like we're creating a table. This is going to act like a table. And this is going to be the first column. It's a string data type. Count is going to be second column. So notice what happens now. Let's say I copy this one. One more time. Copy this one. Oops. Not pasting it today. Click on OK. OK. Let's run it. So now notice what happened, guys. Records. If you just type in records now, notice what happens. It's not giving anything. Interesting. Shouldn't give us an error. It's good. That's actually, this is saying pig is complaining. What's it complaining? Records at line 3. Error during encounter at line 3. Really? They change something. So there is record. So what is it for now? For the sake of simplicity, we'll think of records as a table with 2 columns, letter and count. If you want to see in Hive, you'll say select star from right. We'll say dump records. Now give it a moment. This is where this English-like commands are being converted into Java MapReduce. That is where the code is getting submitted to the place where the data internally on the cluster code is moving. And now notice the results are being dumped. Or in other words, the results are being shown. In other words, dump is what is printing it on the console. It's like saying select star from. Okay, in Hive, you say select star from. Here we say dump. Everybody with me, guys? Quick yes, please. There are a few keywords. These are some of the things we need to be familiar, and we'll try to understand these things, guys. Okay, so that is dump. So what happens is, when we say the first one records, what pig is doing is, it is not really loading the data. Only when you say dump, it is going to, this is called a lazy loading, lazy execution. Unless it is required, it will not really execute it as what it is. That is for optimization. You don't need to go that far. But let's say, if you say explain records, notice it gives you graph-like structures. These are called logical plan. Then you have physical plan. Then you have MapReduce plan. So behind the scenes, what Pig is doing is, it is coming up with these abstract syntax trees. It's building these trees. Hive will also build a plan. An execution plan is what is referred in an SQL word. This is like an execution plan. Pig is building these things and it is hiding all these things for us. Based on these trees, it is generating the Java MapReduce programs. In a real world, we ideally don't have to worry about these plans. That is what Pig is hiding. That is what is meant by abstraction. For debugging purposes, to understand how many maps, how many reduces are happening. For optimization purposes, we will generally go this far, but otherwise it is not really required. But what did we do? Explain records. That is what is called as a explain is giving you the execution plan is something to be kept in mind. You need to be familiar with that, guys. Okay. Now take a look at this. We'll say to print limit records to. If you recall, let's say, paste it, click on OK. And what do? You say dump to print. What is it doing? It's giving you the top 2 records. It's like saying select star from this table records, limit to. In Pig, we're saying limit records to. Everybody with me, guys? Again, that's a slight or a subtle change difference between the language of Pig and language of Hive or SQL. Quick yes, please. Dump is just printing it onto the console or the window. Cool. Quick yes, please.
Sir, go slow, sir. We want to execute now.
Pardon me?
Go slow, sir. We want to execute now. Commands.
Executing. Okay.
Yeah.
Sure. Have you created the file a.txt?
Yes, sir.
Okay, let's see. Give me one moment. So let me explain. See how far you can go. Okay, for a moment, share your screen, buddy. Who's it? Can you share your screen so that others can see? Okay. So limit records to, and let me know if you're done. Next one is describe records. So there it is, guys. This is the schema. Notice what pig is doing is it is storing like this. It is storing records as a dictionary, like a key, a letter, or in other words, this is the data type to be more precise, is what it is. So letter and count, what are these? These are individual data types, basic data types. Pig calls them as atoms. In a pig world, they're called as atom. It is something to be familiar with. Okay, and what is this? This is called the schema. What is schema? Schema is something where it is telling, hey, here is a column name, here is a data type, and things like that. Everybody with me? Quick yes, please. That's a slightly important thing I need you to keep in mind. Quick yes, please. How many of you are typing along with me, guys, in the web shell? Anybody typing there? Okay, Niharika, Pravolika, Praharsha, good. Okay, keep me posted as you are. Have you successfully created the file a.txt like the way I've done? Okay, who's no? Praharsha. Okay, you need to create that one, otherwise you'll not be able to execute. You'll need to take another data set. But let's say for your sake of simplicity, here is cat a.txt. Just to make sure the data is tab separated. The reason we need to make sure the data is tab separated is by default, when you say load, it will take the data as tab separated. b.txt is just characters, okay. I'll save this one, okay. So shall I go to the next step, guys? Everybody okay with this? Everybody okay with the describe? Describe is giving you the schema. Okay, next, let's see what else we have. Next one is explain, we have already seen. Niharika, straight and simple commands, type it. These are not case sensitive, you can type them. If something is big, I will definitely paste it. Okay. A little bit of effort from you will be helpful for you only. Next, take a look at this. Illustrate. Yeah. Illustrate A. Now take a look at A. Oh, sorry. Illustrate records. My bad. So we should say illustrate records. Take a look at what happens. What illustrate is doing is in our data, kite, 6 is one of the rows. Run it again. Cat. There's apple. There is dog. So in other words, what illustrate is doing is it is randomly showing you some records of data. Okay. What is so in other words, each time without really running the Java MapReduce programs, it picks up some data and randomly throws it you or shows you. That is what is illustrate. Okay, have you tried it? Pravalika, Niharika? So now, one more time, what we'll do is take a look at this. Let me see, vi b.txt. See if this works. Okay, it doesn't work. We'll quit out of pig. Say vi b.txt. And we'll say A. Next one C, B, D, B, C, B. Say, so B is 3 times, C is 2 times, let's say D, E, F. That's it. Okay. So AC, BD, BC, BD, EF, you can create your own thing. You don't have to exactly create what I'm creating. I'm going to write it and quit it. Have verified ls-ltr, and now b.txt. Notice there is a log file. Okay, if we say this is a pig is created a log file of some of the things that were going on. We were doing a movement back. It is just to have an idea, pig underscore. Every time you come out of pig, it is saying, okay, it's 75852795777. Okay, get it. So these are all the errors and things like that. It's kind of maintaining what all the commands we have done and things like that. That's just an FYI, I guess, nothing too much. So one more time, we'll get into pig -x local, get back into pig. And now take a look at this, guys. We are going to say, we'll say load b.txt, because we have only one column there. We're going to treat that as character array, which means a string. And we'll say dump characters. We'll run both of them. Oh, I need to paste it. Say paste it. So here is characters. We paste this into everyone. Okay, there it is. I send the code. If you're trying it, first make sure you created a b.txt. Now load b.txt. Now we'll say dump characters. Give it a moment. It's converting it to Java MapReduce program. Notice it emits a lot of things. What is this one? This is the MapReduce information. It is kind of giving us the network information. How many bytes have been read? How many bytes have been written? So during the time of MapReduce that it is internally performing, these are mostly used for understanding and optimization. When you have terabytes and terabytes of data, slightly at an architect level, what they will do is they will see how much of bytes are getting transferred. Right? Is this like a read intensive job or a write intensive job? So every command that we are writing is behind the scenes a MapReduce job. Every MapReduce job is something like counting the books in a library. How many read operations happen, how many write operations happen, and how much of shuffle data is happening. We don't have to worry about it, but at a slightly high level, the architects, all those guys will be looking at this kind of things to see if there is something taking too much of time. Then they will try to optimize them. They will try to write better code and improve the code and data transfers and things like that. So successfully read this many records, successfully stored. Pig is emitting out some information, what it has done here, and so on. Okay, so now if you come back here, so now take a look at this, guys. What is this one? This is a tuple. What's a tuple? If you recall, tuple is something which is read only, it's immutable and things like that. So in pig, again, we have a tuple. So what is happening is originally we just had one data, one letter or character A. So what pig has done is when you dump it, it's putting it into a tuple and displaying it in the form of a tuple. Tuple is like a record or a row in a database. Everybody with me, quick yes, please. Okay, so this is a group of tuples is what it is. And let's say, let me stop the share here for one moment. I'm looking for one thing. Let me quickly come back. Say attaching. Okay.
Sir, break, sir.
You want to break? Okay, give me one moment, buddy. Scrap pick. Okay. Okay, guys. Let's see. Okay, you guys. Let's see where we are. We're at 12:07. Let's regroup at 12:15. Guys, take a 7 or 8 minute break and come back, please. Everybody okay? Okay, guys, I'm back. Are you guys back? Can you give me a quick yes, please? Okay, great. And let me go ahead and share my screen. Okay, there you go. So same. Back to the commands, guys, back to the web shell. So what we just did is we just did a dump of characters. So characters is acting like a table, and in a Apache Pig world, we call characters as a relation. What is a table in a SQL or a Hive world is like a relation. What is records or rows in a SQL world, we call them as tuples in a Apache Pig world, guys. Okay, so Pig is from Apache. Apache is a open source foundation. They are the guys, a lot of people, when they write some softwares which is useful for everybody else, they donate it to the Apache Foundation of the organization. And anything under Apache is open source, guys. Open source means it is free. Okay, so that is just a FI. Now take a look at this, guys. What we'll do is characters load BS text as character array, dump characters is. Now what we'll do is we'll do a group characters by letters. So I'm going to send it in the chat window also. So character group, back here, back to the web shell. Say paste, say paste, click on OK. Okay, now say dump char group. So notice sometimes what can happen is a group of MapReduce jobs can run. Group is a slightly more advanced operation. It is the same group by operation that we discussed in the SQL world, but let's try to understand how it works in this world, guys. Okay, in a pig world, say back here. Oops, put it here. Okay, so start with this. So our data looks something like A, then I think we had a B. Oops, D, C and the B, and I think B and the C. I think then I think we had a B and an E, D, and let's say F. So in our command, what we are doing is we are saying group is a relation, characters, some group characters means take this relation and group it, do a group by what? By letter. What is letter? Notice letter is like a data type or a column name. It is a data type in this relation. It's an atom. In a pig world is what they call it, guys. Okay. So now what that means, what that is doing is visualize. It is going to start with a, let's say, it's going to start with A, and then it is going to match. Does A match with A? Yes, A matches with A. So now what it is doing is back here, it records an A. It records an A here. Oops, by side of it. Then it starts comparing. Oops, back here. Does A match with B? No. D, no. A, C, no, and it keeps going. So what is it there? It is done with A. Next, what does it do? It starts with B. So let's say choose B here. Here's B. Now what it does is it starts with B. Does it match? Is it same as B? No. So here is a B. It matches with B. So what does it do? Well, come here, choose this one, put a B here. More time, say here's a B and put this here. Next, what do you do? Come back here. B is not same as B, not same as B. Again, matches second time, matches third time, matches fourth time. So every time it is matching, visualize what it is doing is internally it is treating, or more precisely, let's say internally it's saying, hey, is the second match, is the third match, here's the fourth match. So that is B. Next, come to C. So here is, say, choose this, C, and we'll also, it looks like we have two C's here. And before we go on to C, let's put a D here. Put a D here. Let's put a E here. Let's put a F here. And so for C, it is matching 2 times C and the C. D, I think it is only matching 1 time D. E also, it's matching only 1 time E. Oops, E, one more time. Is an E. And F also only 1 time it matches. So F. So now this is the second step. It has done a group by. Now visualize what it is doing is, notice for A, there is only 1 A associated A is what it is, but for B, there are 4 Bs. So what are these 4 Bs? There are 4 rows, 4 records. What are they? Now what it does is, come here. Okay, I'll directly show it here rather than typing. Every row, it is converting it to a tuple. Looks like we had 3 Bs there. Okay, a tuple here is more precisely what B is telling it is there. It's a separate row, is what it is. Okay, then come to C, 2 C's. So let's say for sake of simplicity, choose this. Here is C. So that is the first C, and here is the second C. So every tuple really is telling that is really a row. Pig is indicating this is 1 row, this is second row, this is third row. It's indicating like a tuple. And what are these? All these things, it is now creating a table or a relation. In a pig world, they call that as a relation. Similarly for C, it created a relation, put 2 tuples inside it. The 2 tuples are like 2 rows or 2 records. We call them as tuples here. The same process is repeating. For A, that is really relation. How do you know that's a, okay. So now for A, let us try to, because there is only one thing. Let's say, here it puts a tuple. Then what it does is, it is putting it inside a table or a relation. And now what it is doing is, say, choose this one. Here is A, this one, and this one together is a tuple. So notice this left-hand side A is here, and it's inside a tuple. And the flower bracket is indicating it's a relation. That's a pink one. That's a pink one. And the inside tuple is the orange one. So what is it? It is indicating this is a tuple where the left-hand side of it is acting like a key. This is acting like a key. This is acting like a key. The right-hand side is a relation or a table which is acting like a value. Again, in pig also, we think in terms of everything as a key and a value, just like MapReduce. The left eye, so this whole thing is a tuple. Each row here, oops, pardon me, is a tuple here. Sorry about that, guys. Oops, there you go. Each one is a tuple in which the left-hand side key, we have left-hand side key, and the right-hand side is a table or a relation. Instead of table in a pig world, I'll be calling it as relation. For the sake of simplicity, you imagine that as a table, and inside that relation, we have three tuples. Everybody catching it, guys? What is it doing? Ideally, it is doing a group by here. What we discussed in a group by is what is going on. And what it is doing is it's creating, this is called a complex data type. This is called a relation. This whole thing is again called a relation, which we are calling it as char group. Okay, everybody with me? Quick yes, please. Okay, move to the next one. Again, one more time, just for sake of discipline. We'll say illustrate char group. Putting it in the window. And let's say back to the web shell, paste it. So every time we run it, it's going to pick up a random result from char group. So it's running the map reduce, it picks up D this time. If you run it again, it'll pick up another random one. That could be A, that could be E, or whatever it is. It's randomly picking up some rows and giving it to D again, okay. Run it again. C. Okay, see the group character. The left-hand side, the key, what we are referring to, the key is called the group column. The right-hand side is acting like a relation or a bag. It's also called a bag. A bag is a group of complex objects. Again, that is the terminology of pig, guys, in a pig word. Okay, guys. Now let's see, we'll go back to the data set A, back here. Okay. Now notice this, guys. Records load a.txt. I'm going to copy this, put this in the chat window. Okay. Now let's come back to the web shell. Paste it. Paste it. Click on OK. Let's say run it. Oops, one more time. Run it. Now say dump records. It will show you whatever is inside it. So apple, dog, cat, and a kite. Okay, we'll say describe records. Now notice this, guys. Describe, pasting it in your window, paste it here. One more time, click on OK. Take a look at this. Now notice what is records. Records is a bag or a relation in a pig word. It is a flower bracket. It's like a table. It has one column called letter. String, character is nothing but a string data type. A coffee cup, count is nothing but a integer, which is a teacup. It has one coffee cup and teacup. What is this? This is called schema. So what did we do? We already have the data. And what we are doing is we have given a schema when we have done a load. This is what is called schema data. Schema is required. So what we are doing is at the time of reading the file, we are giving the schema. We already loaded the data. In a database world, if you want to load the data, you should first define the schema. You should say letter is a string or a character array, varchar, and things like that. And count is an int, and then you will load the data. If you recall, in Hive, we do the create table first, and then we do the load data. Everybody recall, guys? Quick yes, please. Here, we have already loaded the data, or in other words, the data is there. We can do a Hadoop FS put also, we can load the data, and then we are. So here, schema is required at the time of reading. In SQL world, schema is required at the time of writing is what it is, guys, okay? So describe records. Now take a look at this, guys. Now, what is this one? This is like a for loop. For each records, generate count. What is count? Notice count is a column in the file a.txt. So what we are doing is, for each records means, go to the records relation, the bag or the table. For each means take each tuple. Generate count means select count. In a SQL world, we'll say select count from table records, from records. Here we're doing the reverse. From records table, select count is what you can think. So if you say, copy this one, put this here, and let's run this one. Paste it. Paste it again, run it. And now say dump counts. Notice Sorry. What happened? Counts equal to for each record. Or num count, sorry, not count. Okay, so it is running its Java MapReduce and it selected the second column, which where these are the values 1496. So back to cat, and what is it? Our file is a.txt. Notice that one. Okay, now we'll do, say, here's the counts. Here's letters. We'll say tt letters. Letters is nothing but the first column. So in other words, this is, let's say, we'll call this as words. These are words, which is I want all the first columns. Words. For each records generate letter. Okay, let's run it. Say dump words. Give it a moment. Apple, dog, notice they're coming in the form of tuple. This group of tuples is called a bag or a relation. That is the Apache pig. Oops. So I'm going to copy this one. Copy this. Paste it here. Sending it here. Dump is used for display. That is true. That is right. A more simple answer is dump is just displaying. Everybody with me, guys? Quick yes, please. So here, what is called letters, I'm using words here. These are nothing but words because we put the words there, dump words. Okay, now take a look at this, guys. There is a subtle difference up here, but with a subtle difference. The first time when we did a load, we said load a.txt as letter and count. Letter and count, what are they? They are acting like column names. Now take a look at this. What we are doing is, let's say, we will not give the schema. Schema is not required. We'll just say records load a.txt and notice, say, copy this one, pasting it for you, pasting again. Let's try the load a.txt, dump records. Schema for records is describe. Now take a look at this, guys. What I did is, I think I did two steps at one time. Where I said load a.txt. So load the file, we did not give any column names, but then you're saying describe. Describe means you're giving the schema, the metadata. Notice what it is saying, schema for records is unknown. In other words, what it means is, for pig, it is not a must that you give the schema. Even if you don't give the schema, what will happen is pig will automatically load it, is what is the meaning of that. Now, why is it important? Take a look at this. We'll say dump records one more time. Here is dump, oops, one more time. Dump records. Give it a moment. Notice apple, dog, cat, and kite. These are the records. Everybody with me? Quick yes, please. Okay. So now what is different is, notice this one. What we can do is, we can say for each records generate $0. This is called positional referencing. When you do not have a column name, you can still refer the first column as $0. So let's say copy this one more time, copy this, sending your way back to Excel. Okay, now say dump zeros. Notice it is going to extract the first word, apple, dog, cat, and kite. Similarly, you can also zeros, you can say ones. Here, this is like a variable on an object name that is called relation or a bag in a pig world, guys. Okay, notice what we are doing is, for each records generate $1, $0. We're just changing the order of the second column, so it is following zero-based index again. So let's say copy this your way. Let's run it. say dump once. So now it is going to display the second column on the left hand side, the first column on the right hand side. We can change the order. And where is this one more useful, guys? In the world of big data, generally, you will now not have one or two columns. You will have tens, hundreds, and thousands of columns. If you have to give a schema, if you have to name every column, okay, every column, when you have hundreds and thousands of them, it becomes very, very unproductive. What do you do? That is where the positional referencing comes to a picture. Okay, you can just load up the data. Let's say you want 333rd column, which is interest. What do you usually do? You say 332 and it will extract 332. When you have hundreds and thousands of columns, there are a few columns which are important. What do you do? Without you can load up in Pig and just select those columns and save it back to another data set. Catching the point, guys. Quick yes, please. Now let's see what happens when you say describe on this new relation of the bag that we created. So let's say paste it. Say run it. Notice what is happening is byte array and byte array. It is giving you, it is treating it like a relation or a bag or a table with two columns. In the two columns, what it is saying is it is not giving a character array or an integer. It is saying it's byte array. Byte array means it's like bytes. Bytes means binary data, which means this relation, Pig is treating it like a binary data internally. Something to be aware of. Everybody with me, guys. That's a slightly deep one, but quick yes, please. And remember, $zeros, $ones is positional referencing. Niharika, Pravalika, Suresh, are you guys doing okay? Are you catching it? Okay. So next come now take a look at this, guys. What we are doing is, for each ones, we are going back to ones, which is we have the $1 is nothing but the indexes 1, 2, 3, 4. $0 we have the words. Okay, now notice this. Test ones for each ones generate $1 as X and $0 as Y. What is X and Y? X and Y is like an alias. So let's say copy this one, give it to you, and come back here. Paste it. Run it. Now what you do, you say describe test once. Now notice what is happening. Earlier, it just gave a byte array and a byte array, no column names. Now it has given the column names as X and Y. They're byte array, which means Pig is treating them as binary data. Why? Because we did not say whether it's a character array or an integer. But the column names we have given, so it is treating it as X and Y. So if you say dump test once, it will give you, let's say, oops, dump it. Give it a moment. There is the data. $1 as X and $0 as Y. And this is test once, right? So what do we do? Describe test once. We did test once. $1 is, again, we just changed the left-hand side and right-hand side is what it is. That's what that is. Everybody catching it, guys? Everybody following it? We're just doing a dump here. When you say $1 is X, you're giving the first column as X and the second column as Y. Whatever is on the left-hand side, the name, the friendly name of that, you're calling it as X. It's like giving a friendly name. So when you have a lot of columns, you just first load the data, give your friendly names to it using positional referencing. Quick yes, please. Okay. Now take a look at this. We're going one step deep. What we're doing is generate $1 as X and character array. This is called casting. This is where we are converting the type. So what we're telling Pig is, whatever you have in this column as X, convert it into a string. Whatever you have, this one you leave it as it is. So in other words, let's say we'll run this one. Run this one. And one more time here. Okay. So now X is coming as a character array. So what is this one? This is called casting or type conversion. You can convert it to character array, integer, float, whatever you would like, and things like that. That's called casting, type casting or type conversion, just like we convert strings and integers in Python. Everybody with me, guys? Quick yes, please. Okay. Okay, now take a look at this. We are again doing a group letter by. So sending away like here. Paste it, oops, undo it. Oh, oh, group letters. I think, what is this one? I think it is named as group words, I think. Group words. Okay. We named it as words. Back to web shell. Give it a moment. So now cat is appearing only one time, dog is appearing only one time. So notice it's a tuple inside which cat is sitting on the left hand side. That is called the group by key column. And this is a relation in which there is one row. If there were two cats, it would be cat comma cat. That's what it is, guys. So what is words here? Words, if you scroll up here, we have given this earlier. We said for each records generate letter. Generate letter is, again, letter is nothing but a character that we created earlier. So where were we? We were here. So just once, okay. So describe group letters one more time. Paste it. Run it. So the left hand side column is called the group by column. The right hand side is called the value column. That is generally a relation of tuples. It's like a table. It's sitting like a table with a group of records inside it. Catching it, guys? Quick yes, please. Pardon me. Okay. Okay. Let's see. Now take a look at this, guys. We're increasing the complexity here. For each group letters, generate group count of letters. Remember, we're going to, for each group letters means we're going to go to each row. Generate means select. Group means the left-hand side column. By default, when you create a group by, Pig is going to treat the left-hand side column as a group by column and count of letters. So let me run this one. Back here. Take a look at this. Okay, group count of letters. See where is letters here. What's that? Group letters. This should be words, I think. Let's call this as words. Rename letters as words. Click on OK. And we'll say dump count. And before I run this one, what I'm going to do is I'm going to copy this one back here. Paste it here. Oops, it's not picking up. Copy this. Paste it here. Okay. This one. Okay. Save this one. And now count of words, and we'll say dump counts. Dump counts. Run it, give it a moment. And now notice what it is doing is cat is 1. So what is it doing? It created a tuple where It's saying cat, and it is giving a count on the table. How many cats are there? Well, there is only one cat, so that's why you're seeing a cat one. Dog, kite, apple, what are they? They're also one. So if there were two dogs, this whole thing, that will be dog two. Okay, if there were two dogs earlier, it would have been like DOG and DOG. Everybody catching it, guys? Quick guess, please. Okay. And let's see. So what is happening is count. What is count? Count is like a built-in function in pig. And generate. Generate is like a select. Group is whatever is on the left-hand side. So here, what is this one? Whatever is on the left-hand side, that is the group by column. Because it will be prior to this step we performed a group by. It is creating a pattern where the left-hand side is a group by key column, and the right-hand side is the table itself. Yes, please. Okay. Move on to the next one. Okay. So that is the group by, again, something we need to keep in mind. Okay, next one seems to be unstructured data. So what we'll do, we'll say quit, say bic.txt. So here is start with Mera, Bharat, Mahan. Next say Hamara, Bharat, Mahan. Next say J, him. Okay, and let's see what else we have. Okay, keep it simple. Just a plain and a c.txt is a unstructured data. Ideally, in real world, that would be really in millions and billions of lines. Or in other words, that is generally a very, very big file in terabytes and things like that. So let's see now what we're going to do. From here, we're going to load this file. This is completely unstructured data. And what we're doing is, our plan is, we'll call this as c.txt as line char array. Okay, so in other words, we're going to call the entire line as one column. Char array means we're telling it to treat it as string object. So sending it your way. Oops. Okay. So right, paste from browser. Click on OK. Unexpected total. Hey. Try it again. This one. Did you leave anything open here? Oh, my bad. Sorry about that. Thank you. Who was that? Shabazz. Thank you, buddy. I'm running that in Linux command. I need to get back into pig, guys. Very good, Shabazz. That would have been a tough one, actually. But that's very good. Space from double lines of text. Now let's run it. Okay, so now notice what is happening is every line, it has created a tuple out of every line. Hamara Bharat Mahan Jai Hind looks like last line is just empty, is what it is, guys. Okay, everybody with me? So what did we do here? We just said load. So every line is, the schema is going to be, the column name is going to be line, and each line, each row or each cell will have the whatever is in the line. Quick yes, please. Thank you. So now take a look at this. Here's a slightly deep one more time. For each lines of text, generate tokenize of null. Okay, let's say Run this one. Tokenize and say dump token back. Let's run it. Give it a moment. And now, can you tell me what is happening, guys? This one here. So in other words, when you dump token back, oops, certainly. This strange. Strange. Okay, it's not allowing, but notice what happened is Mera Bharat Mahan. Earlier, if you look at the previous output, here is Mera Bharat Mahan. It looked like a tuple with a coffee cup. So what is tokenized? Tokenized is splitting. In a Python world, it's nothing but a split. It is separating one line into 3 words. One coffee cup into 3 coffee cups. So go scroll down here. Okay. So Mera has become one coffee cup. Bharat has become another one. Mahan has become another coffee cup. What are they? They're atoms. Now they are sitting. So what has tokenized done? It has taken each line. It is splitting the words or separating the words by a space. Catching it, guys. Quickest, please. Tokenize, as the name suggests, it tokenizes. That's what tokenizing means. Tokenizing means everything separated by a space. Separate them into separate tokens. That is what that is. Cool, guys? Okay. So let's see if you can understand that. Okay, so notice how it appears. The left-hand side is going to be its key column. The right-hand side is going to be a dictionary of character arrays. Quickest, please, everybody catching it? This is a slightly tough one, increasing the complexity here, but that's what that one is about. Okay, so now what we'll do, we're going back to this token back, generate flatten of $0 means we're telling it, give me the first column. $0 means the first column. So let's say what happens here. So now take a look at this, guys. And say dump flat back. Let's run it. While it is running, let me paste it here. Okay, so if you notice, what is happening is every word got separated into a separate tuple. Mera Bharat Mahan, which was one coffee cup, has become 3 independent coffee cups. That's what flatten is doing. Okay, and let's see where we are. Okay. Gentlemen, ladies, everybody following this, guys, can you give me a quick yes, please? Okay. Okay, guys, let me do this, guys. Let's take a break now, exactly 145 regroup, 150, and we'll continue the journey from there, guys. I need to take care of something, so it's better I take a break and at this time rather than a little later. Everybody okay with that? Thank you, guys. Let's meet in 45 minutes again. Thank you all. Oops, cancel this. Go to participants. There's Niharika, my co-host. Say Lokesh. Oops. Niharika, Lokesh, if you're back, can you make me the host, please?
Yes, sir.
Thank you. Pardon me. Can you make me the host? Oh, sorry, I think it's coming up as my daughter's name. Let's see.
Yes, sir. You are the host.
Right, thank you. So let me share this. You told here. Okay. Thank you, Niharika. So let's see where we are. Okay, so now going to slightly more advanced concepts, guys. Let's say tokenize, we have seen. What tokenize is doing is it is separating a group of tuples, getting errors for every command. I think, have you created the first file, the c.txt file, Niharika?
Sir, first a.txt from that command onwards I'm getting errors, sir. It's giving the failed.
How about c.txt?
Not right, sir.
Create,
Yes, sir. For that also same, it gives error. Same error, sir.
did you get into pig using local mode or?
I'm using big. I first ran big command, sir. Later I executed these lines of text, all those things. Load seed of text. Same issue for public.
Share your screen, please.
Okay, sir. Sir, 1 minute.
Yeah.
Yes, sir.
Now do a ls-ltr. So you created C, do a cat on C. No, sorry, where is your c.txt?
C not done, sir. A.txt and B.txt done.
Show me A.
A.txt.
Okay, why don't you do a vi c.txt or just do a cat on pig underscore one of the files. Any one file is okay. Cat. No, cat.
Cat.
Any one file underscore. No. There's a pig. There are a couple of pig files you're seeing, right? The log files. Cat them. Any one of them.
Yes, sir. Okay. So 1 minute. I have to paste it from browser.
Okay. Now what we'll do is we'll load up this file now, do pig -x local, get into the pig using the local mode. Pardon me. And you have the commands I sent you, right? Load up the C file. Load up the C file. I'm sorry, pig file. Do a load off and paste.
Lines of text. Load C text.
Instead of C.text,
.txt. That one, sir.
instead of C.text, load the pig file.
Okay.
Check the last line. This is disabled. What is last line? Pravalika, whatever, I didn't get your message. Can you tell me what I need to do?
The last ATS is disabled since yarn timeline service enabled set to false. Because of this, it seems we're unable to process that.
You're unable to process what?
Dump statement.
Oh, is it? Hold on 1 second. Let me complete. No. The load complete except c.txt. Give everything, Niharika. You
Okay,
have to
sir.
do the schema there.
Like this, load A as a line colon char array.
No, give the name of the pig file.
Log file.
Pig file. The pig underscore, whatever that is, give it within quotes.
Okay.
Cancel that.
Entire thing, sir. I didn't get, sir.
Indaka c.txt place low, within quotes, within single quotes, paste the pig file.
Okay, okay.
Within the quotes.
Yes, sir.
Okay, so now dump lines of text. So now it should display all the content in relation lines of failed to produce result, failed to read the data.
Same issue, sir.
Pig underscore 16. Do you have that file? 1641. Is that file there? Do a ls again. Do ls-ltr. Hold on 1 second. Let's see, choose any other file here. What do you have? You have a.txt, right? Do a cat of a.txt.
Okay.
Do ls star.txt. It's not showing. Let's see, are there any txt files here? Just some with some stuff inside them. You have hi DR1. Scroll up a little bit. Pause. Okay. Why don't you create a text file? Just exit this one
Okay.
and get into the VI editor, say vic.txt.
Okay, sir.
vic.txt. Type in Mera Bharat Mahan in one line, Hamara Bharat Mahan, Jai Hind in another line. Pardon me. And Bharat Mahan, no. Type in again Jai Hind. Okay. Right and quit it.
Yes, sir.
Okay, now get into the pig in the local mode. Okay. Now load up the c.txt just like you did the other one. I think you need to say load something is c.txt.
Like this. Sir, with the name?
You give c.txt instead of the pig file. There you go. Lavanya has sent it to you.
Yes, sir. Sir, same. Getting same.
Is it done? c.txt.
No, sir.
Failed to read the data. Home big data user 120. LS, do an LS.
Can I scroll up, sir?
You have the file c.txt.
C.txt.
Oh, you can keep looking like that. Do a quit. LSLTR.
Yes, sir. C.txt is there.
Wait one moment, it's still coming up. That is c.txt, okay. Looks good to me. Getting to pick again. Local mode.
Okay.
In your big data user 120, okay.
Phoenix local. Yes, sir.
Load up C again. You make sure you're giving the right file name.
C.txt only, sir. Same.
Load it up.
Dump.
Dump lines of text, yeah. It says failed to read file home /. Scroll up a little bit.
Yes, sir.
Scroll up a little bit. Let me see the error message on the top. Hold.
Okay.
So let's see, lines of text map only. No such file or directory. You're in the which directory you're in? Just do a pwd. Okay, big data user 120.
Yes, sir.
And it says it's unable to read big data user 120 seed or strange. Okay, quit out of it. Do a Hadoop fs -put c.txt. Let's load it up into Hadoop. c.txt space, yeah, okay. Let's see if it executes. Okay, now do a Hadoop fs -ls. Let's make sure c.txt is there. Okay,
Yeah.
now just say pig and enter. So this will be map reduce mode. Now once again do a load of c.txt.
Okay, sir.
It's running now.
Yes, sir. It's running.
So for some reason, it's not able to read from your local directory. That is very strange. Maybe the permissions are not there or something for the Hadoop. So there is Mera Bharat Mahan, Jai Hind, and Hamara Bharat Mahan. Okay, let's do the next step. Let us see what is the next step here. Tokenize, I'm going to send it to you. So I put this here. Okay, here's the tokenize, run that and dump it.
Okay, sir.
Oops.
Oh, something is.
You didn't copy it properly.
Copied, sir.
Have you done it?
Yeah, doing, sir. 1 minute. Yes,
Dump it.
sir. Dump. It's running. Yes, sir.
So what do you think is happening here, Harika?
Later, it is copied to the Hadoop. It is executing, sir.
So in other words, every word is separated in a line. Mera Bharat, where you see Mera Bharat, what
Yes.
kind of an object is it? Is it?
Tuple.
And it is inside a
Dictionary.
it
Set.
looks like a dictionary, but in pig it is called. Set is a good word. That is also Python, but in pig, what do we call it? In pig, we call it as a relation or a bag. Okay. The flower bracket is a relation or a bag, and that relation or a bag is inside tuple. So it's a tuple which has a relation, which is like a table, which has two tuples, Mera, Bharat, and Mahan, right?
Oh, yes, sir.
So what tokenize is doing is it is separating each word into a separate tuple. All these tuples are being put into a relation. Are you catching it, Harika?
Yeah, sir. Yeah,
Okay.
sir.
So that is tokenized. That's a slightly deep one. Let's see. Now here comes a slightly tough one. Let's say, oops. Okay. Okay. Run it and dump the flat back.
Yes, sir. Flat back.
What do you think is $0 code?
$0.
$0
No,
is
sir.
what?
Column index.
Good. It is acting like a column index. It is called positional referencing is what it is. And you're doing a dump of it. Okay. Do you remember what is generate code?
Generate is called select.
Good.
It's like select.
Good. So what do you think is this output we got?
It is taking one by one tuple and made it like one column. Like selecting the column.
Okay. Let me share my screen for a moment. I'll explain this to you.
Okay.
Okay, and then I'll give it back to you. So let's say this is output we are getting. This is output we are getting. Mera Bharat and so on. So what we have done is we have done a flatten here. And what we had was, let's say, we have, we didn't have the output, okay. So if you recall, we had a tuple, first tuple, then we had a second tuple, then we had a third tuple and so on. In the first one, I think, from what I recall, we had a relation. Say I choose, we'll give this for a relation. So it had a relation, which is like a group of tuples again. In that, there were two tuples. So in this relation, it's like Mera Bharat and, so I'll put Mera Bharat here. So you had in your output Mera Bharat and another one is Mahan here. So now let's say I come back here, let's choose this one. Choose this one. The way you had it was, here is Mera Bharat. This was in the first tuple. Here is Mahan. Okay, now, so what is happening here is, this is a tuple. The green one is a relation and the internal yellow ones are two tuples. So inside a table, there are like two rows is what it originally had. That is like a bag. So what it has done is visualize it is taking Mera Bharat Mahan from here. Ideally, you visualize as if it is taking Mera Bharat Mahan here. When it moves here, for the sake of simplicity, I'll cut and paste, but it is copying and pasting it here. What is this? This is flattening. Then it takes Mahan, copy and paste here. It comes with the tuple. Now repeat that here and here. And what is that? That is what it is doing. That is what is flattening. Okay, what is flattening is, this is one dimension, this is two dimension, this is three dimensions. This has become actually one dimension. Actually, to be more precise, these things will be like this one. This group of tuples will go like this. So what you are seeing here is a group of tuples, which is like that. So in other words, this is more like it looks like a two dimension, but we'll call it as one dimension. Flatten is converting a three dimension into two dimensions. Or more precisely, it's like one dimension is what we'll call. Okay, these are all individual rows. Tuples are rows and inside a table. So we can think of that as it is reducing the dimension. That is what flatten is doing. Are you catching it, Harika?
Yes, sir.
Okay, what about others, guys? Can you give me a quick yes, please? Are you catching it? It's a slightly tough one, guys. Okay, so stopping my share. You share your screen again, Niharika. Sure. Okay, and let's say come back here. Okay. Let's describe it. Describe the flat bag.
Yep. Okay, sir.
Okay. So flat bag is a bag of token tuples, token character array. That's like a relation. The flower bracket indicates the left-hand side. Bag of token tuples, colon, token means that whole thing is a column name. It is reading it as a token. Because we earlier tokenized it, it's giving a column name called token. Character array means it's a string or textual data. That is again the scheme of it. That is something we'll need to kind of get familiar. Okay, now let's see, here comes another tough one. Okay, run the letters.
It's running. Sir.
What do you think substring is doing, Harika?
Letters equals to for each by the flat generate substring. It generates one like index separating. Oh, substring yum. In the Mera Bharat, yum is
Why is it taking M?
given. Mahan I given starting with A. Jai Hind.
Why is
First
it-
letter.
Why is it taking the first letter?
Flat bag for each. I given generate substring.
And what's substring doing?
It takes first letter.
Okay, in other words, substring is where we are giving the index 0 and 1 from 0 position up to 1, which means it's extracting the first letter, right?
Oh, yeah.
Okay, run the letter group and dump it.
Gives entire.
Let's see if you can explain this.
It's still running, sir.
So that is big data. Generally it runs slow. So if you want to improve the performance, what are some of the things that we could do, Harika?
We can close all other things.
No. In Hadoop.
Hive is the fastest.
So in Hadoop, you can add the resources for big data. This is small amount of data, but generally if you add
Okay, by
more
adding
servers, you'll be able to improve the performance. Now explain me the output here.
letter group, group by letters by letters means for I can no sir. I didn't get it, sir.
So A is appearing one time, B is appearing one time, H is appearing 3 times in the input that we have taken.
Okay.
The left hand side A is the key, the right hand side is a value which is a relation in which it is selecting how many times the A is appearing. Okay, run the next one, count per letter and dump it.
Count per letter.
Okay.
How many times A is coming, A is present, and how many times H is present.
Okay, so now let's say run it.
Yes. Yes, sir. Can I dump?
Yeah, dump it.
Oh, something else. Sir, I did a mistake. I dumped some other command.
Let's see, let's wait and see.
Okay.
Is it done? Still running up?
Still running, sir. 50% complete.
Okay.
Yes. It is giving H3 something.
Okay, what do you think is going on there? Dump the one we
I
just
dumped some
created.
other thing. Ordered.
Yeah, dump it. So what do you think is going on there, Harika, while it is running? When you look at the statement, what does it look like it is doing?
Map reduce. It is processing.
When you look at the statement that we have run, ordered count per letter, what do you think it is doing?
It is decrementing index 1.
Decrementing. Think again.
Descending order. First index is giving in descending order.
So what is happening there in Shaiba's output? What is happening?
Second column index is decrementing.
What does it mean, Harika?
Number of m's, how many is there? It giving.
But how does it know it is second index?
Second index by $1.
And what is order by?
Order by it's arranged. It taking as a. It arranges.
In SQL, what did we use order by for?
To sort it in one format.
Now you're understanding? Now you're understanding why we are getting that output? Bring up that command again.
No, sir. Command.
Bring up the command again.
Okay. Order by count per letter. Descending order.
What is count per letter here?
Count per letter is counting the number of
Relation of the bag.
Okay.
And what is order by?
Order by is sorting.
$1 means?
Index.
Second column.
Second column. Second.
Okay. $0 will be first column.
First column.
If you have to write this kind of a statement in SQL, how will you write?
Ordered by index column 2, whatever the name is.
Let's say count per letter is your table name.
There. Okay.
How will you write an SQL statement?
Select all and from ordered count per letter and order by second index means I need to know the column
As
name
simple as
also.
that. So that's what this is doing. This is big way of doing it. We'll say select star from count per letter, order by $1. Instead of $1, we'll give the column name and we'll say descending, right?
Yes.
Got it?
Yes, sir.
Okay, then let's see. Okay, run the next one.
Okay. One minute. Dump result.
What do you think that is?
It is limiting to one value.
Means?
One row.
What is it?
One row. It gives only one first row. I think.
Okay. Okay. I sent you something. You need to create a text file with these 3 columns. After this one, you quit out of pig and create the d.txt with these 3.
Okay, sir.
They are tab separated.
Okay.
What does it mean by tab separated, Naharika?
Rather than one space, we need to give tab.
Good. So limit means limit is just selecting the top one row, okay?
So this one gives based on this value now, sir. Ordered count per letter, 1 means first one, 2 means first 2.
It is only going to select the first row because we said limit row 1, limit 1.
Okay. If it given 2 there, then it gives first 2 or first.
It'll give the top 2 if you say.
One. Ordered count per letter space 2. It gives first 2.
Limit 2 will give you 2 rows, Neharika.
Yes, sir. That's what.
Still running up?
Yes, sir. Still running. $75. Very slow.
Strange. Okay. Try
Yes,
doing,
done.
try doing Control C.
Completed, sir.
Good. You quit now? Okay, that's okay. You go ahead and create the file.
Sorry. 1950. Tab space 12. Tab space 1. Enter. 1960. Tab space 13. Tab space 2. 1970. E 3. Sorry. Escape. Title group. Sir.
Yeah.
T.txt. Can I go to big local or
Put it into, load it up into HDFS.
okay. FS -put D.T. Yes. FS -ls. It's present.
Get into the map reduce mode and let's see. Run this one once you get into the map reduce mode.
Okay, sir. TXT. Create a log file. Sir, done. Failed to read the data.
Oops. You need to change the location of the, correct the location there.
Home/user. Home big data user. That one. I need to give.
Okay, try that.
Okay. Slash home/big data user 20 slash new data to slash data. Okay. T.txt. Instead of dump temps. It's also failed, sir. Failed to read.
And it's reading from, so Bring up the command you just wrote.
Bring up the command.
Bring up the previous command, load command.
Okay.
Just remove everything, just keep d.txt.
Home and d.txt or
Only d.txt.
complete. Okay.
d.txt, that is the name of the file you have created, right?
Yes.
Now load it. Then dump it.
Temps. Running. It's running.
Okay. So still running now?
Oh, yes, sir. It's running.
When you say load like this, what is happening? Do you recall, Harika? It's a tough question, but what do you think is happening?
It is creating log files.
And
It is creating log files and dumping means executing.
okay, let's see, I'll give you another one here while that is running. Okay, so we have dumped it. Now take a look at this one. Tell me what is the difference between this one and the previous one.
Load txt. Okay.
Run it. While it is running, I want you to look at it, give a thought, what is the difference?
It gives a relation. It gives a relation.
What is relation here?
Here character array 1.
Is that relation?
Temp int 1.
Is that what you're calling?
It is like key and value.
That is called schema. Column names and the data types.
Okay.
So in the second scenario, when we say temperatures is low, we're giving the schema. In the first scenario, we did not give the schema, right?
Yes.
That is the difference. Okay. Now let's see.
Okay.
Okay. Here is the next one. Run it.
Yes. Dump. Corrupt underscore. Yes.
So what do you think this is doing? What do you think is happening here, Harika? That's a tough question, but others also try to help Harika guess.
By dump is dump display.
Take a look at your original data and take a look at the output. What do you think is happening?
First, filtering the second column, like second index. By the temp is null. Corrupt. The temp is null. It is emptying the null characters.
It is?
It is emptying and it displaying the null value in that character array place.
Good answer. It is selecting all the records where something is null. What is null?
Character array.
What is character array?
Character array. Display value.
What is temps here?
Temp is a entire thing.
Temps is the relation. What is temp here?
Yes, sir. Temp is a integer type of character. This second index, the second column is that is a temp.
Temp is temperature.
Given.
Temperature is column name.
In column name.
Temps is relation. Temperature is column name. Okay.
Mm.
So why are we calling them corrupt records?
Calling corrupt record. I don't know.
So all the records where the temperature is null, which means where we don't have any temperature, those are all the records which are corrupted records. Okay.
Mm. Yes.
You understanding?
Okay.
Okay. Run the next one.
Yes, sir. Temp by temp, not null. Temp records. It filter out which are not null
Pardon me.
from the temps. It filter out what are not null in the temps relation. By
So what are
column.
they? If they are not null, what does it mean?
It is integer. Anything
They're valid
temperature is
records.
recorded. Any temperature is recorded there.
If they are not null, that means they're valid records, Harika. Okay.
Okay.
So what are these two steps doing?
One is keeping the valid records. Before that, before one is it emptying the invalid records.
Very good. As simple as that. We're separating the valid and the invalid records, or we can say we're filtering the valid and the invalid records. Okay.
Okay.
Okay. So let's see. Run the next one.
Report records. Okay.
And explain me, what do you think is happening here?
It groups all corrupted records.
Okay. So this is grouping all the corrupted records. How do you write a statement for grouping all the valid records? Just put it in chat window.
Okay. Grouped underscore. Records equal to group records on. We name it as records. One minute.
Would not. Dump it, please.
Okay. So,
What's the problem?
nothing, sir. By mistake I hit enter.
Good.
Sir, it is given remaining valid records.
So what do you think that this is explaining?
We stored valid records in records with the name records. Those are giving us.
So in other words, all means all the records is
Which
what
are-
it is. And let's see. Okay. Now, here's a slightly tough task for you, Harika. This is maybe an advanced question, but give it a try. I'm going to send you something like this. Do you remember what this has done? Don't run it.
Okay.
What do you think this was doing?
For each letter group, generate group. Count the letters. It creates it selects, generate means select. It selects the column first one and group by letters. Maybe it count letters like by group,
Okay.
grouping it.
Okay. Now, the output that is displayed to us, what kind of an object is it?
This one tuple.
Couple of
In the tuple of two tuples in the set, like relation in this big.
Okay. Can you write a count
Two tuples.
statement like the one I have sent?
The same or I have to write.
Can you try to write a
Right, and then-
count statement like the one that I have sent you?
No.
What is the name of the previous
No,
relation that you
sir.
created? What is the name of the previous relation you created?
Okay. Okay, come. Group of records. Records. Records, sir. First.
Okay. So let me do this.
Before that, tense.
Okay, let's see. Let's see if somebody sent it here. Temperatures. Okay, see if this one will work. And I think instead of group records too, you have group records, I think.
Hmm.
Change it to group records.
Group records. Okay. Group records. Remaining is same.
No. In the one that I have given you, I have given for each group records to change that to group records, not to.
Okay. Running. It gives two. Two means this index. Column number 3. Group records generate count. Result.
Can you take a guess?
Sir,
How
for
is it?
each group records generate count, how many records are there? Valid records, how many
Good.
records are there? It give
As simple as that. Okay.
okay. Yeah.
And okay. Okay, bring up let's see, give me one moment. We're having, I actually wanted to start cloud today. Looks like we're having some issue. And let's see, what time is it? So take a short 5 to 10 minute break, guys. May check how the Azure is going on. Thank you. You can stop sharing, Niharika.
Yes, sir. Sir, how to see history in the pig, sir?
In the pig, I don't think you can look at the history like that. You'll there are these log files which are getting saved every time. That's where all your pig commands are getting saved. That is one way. Okay.
Okay, sir.
Okay, guys, are you back? Can you give me a quick yes, please? Okay. So let me bring up my screen here. Okay, today we'll get started a little bit with Azure cloud computing, guys. And it looks like there is some issue on the labs going on, and our folks are looking into it, but we'll try to do on our own some of the labs from a different account. And maybe by tomorrow, you'll be able to access the Azure lab and things like that. So let's get started here, guys. Bring up my chat window. Okay. We'll try to understand a little bit about what is cloud computing, what are the different kinds of models and services available in cloud computing. So let's see, the first one is cloud computing. It is nothing but it is ability to harness the power of computing on the internet. In other words, stop my share here for one moment. Share it one more time. And slide, say share it. Okay, hope you guys can see it, guys. Okay. So, ability to harness the power of computing on the internet. In other words, more precisely, what we are doing is we are performing the computations on the internet rather than performing the computations in our local server is one way to think of it, guys. Okay, we are harnessing the power of computation on the internet is what it means. It's over the internet, it's easily available. So in other words, the only thing we need to work with cloud computing is internet. It allows you to use a variety of resources. Little or no initial investment is needed. So in other words, what are the different kinds of resources we'll try to discuss, we'll try to get an idea about that, guys, okay? Little or no initial investment means very minimal investment is needed. Imagine we're a company, we are trying to set up an IT department or maybe an analytics department. We need to set up the network, we need to buy their laptops, lots of hardware, lots of other kinds of software. all these things as investment that would not be needed if we were to adopt the cloud computing. And how is that possible? That's what we'll try to understand. It is flexible, use whenever you want. In other words, you can use it from anywhere, whether it is from home or work. It gives you that flexibility, as simple as that, guys. Okay. So again, we'll dig into a little bit of these details. So let's say here is a quick example. Imagine we are setting up an IT company. And what do we need to do, guys? Well, we need to first hire a group of people who are the network engineers. And what will they do? Well, they will set up a group of servers, physical servers, storage, the other components of the servers, the RAMs, the racks, the clusters, and things like that. In other words, we need to invest in networking department. We need to build a data center, if not a full-fledged data center, a small data center. Generally, in small companies or medium-sized companies, you will see a room or two are allocated where they put all their servers. And inside that, they need to be secure. You need to provide air conditions because the servers can get hot. And if they get hot, they will run into maintenance issues. And if they run into maintenance issues, we may need to stop the servers. If you stop the servers, your data will be unavailable. So what do? Well, you invest in security, you invest in cooling, you invest in ongoing maintenance. So in other words, we need to constantly take care of the maintenance. What is common among all these things? Money. There's a lot of money which goes into setting up a host of servers or a group of servers is what it is, guys. Okay. Everybody with me so far? Quick yes, please. So that's why cloud computing comes to rescue. Cloud platforms like Azure makes things very simple. We will see in the coming up days how simple it is to work with cloud computing. We have the ability to create a virtual server on the internet. So in other words, all the things that we just discussed, we will not do any of these things, which is, if we go one step back, we don't have to build a data center. We don't have to set up a security room or security guys. None of these things will do. Everything will be taken care of by the cloud service provider. And we can create a server on the internet. How? That is what we'll see. We don't need to manage aspects such as physical server networking, which is what I just discussed. We don't need to make an initial investment. We'll try to understand how it is possible without making an initial investment, how it is possible to do. You only pay for what you use. Okay. So in a day, if we just used it only, if we use the server for 5 minutes or more, maybe 1 hour or maybe 2 hours, we will only pay for that. We don't have to buy a big server and put a lot of money into it and try to put a lot of investment. All that will be saved with the help of cloud computing, guys. Okay. So going a little bit deep, infrastructure features. Generally, when we are putting up an IT company or a traditional company, again, we buy a lot of infrastructure. We have to ability to distribute the resources across regions. Imagine we are working with a very, very important client. And let's say it's financial data or banking data. And we need to give high availability. High availability means at no point of time we cannot afford that customer, that our banking customer, if anybody logs into their application, at no point of time, we cannot have the application unavailable. We should always. So what do? Generally, we distribute. What are resources? Resources can be many things. They can be the servers or they can be the components of the servers also. We can add high availability to your architecture by using services such as Azure Load Balancer, Traffic Manager. In other words, load balancing. If you have 5 to 10 users or maybe 50 to 100 users, let's say you built an e-commerce application. You have 5 to 10 users or 50 to 100 users. What will you do? Well, nothing much. You can, traditional web applications without much sophistication will serve them, will work them. But imagine you are selling some very good products and suddenly all over the world, a lot of customers are coming to your website, and what happens is there's a lot of load on your server. Now, for every 1 second or maybe 1 minute, 50,000 to 100,000 customers are hitting your server. So what do you need to do? Well, you need to make sure the server is not down. You need to make sure you're able to handle the traffic. That is where the load balancing and the traffic manager comes to your rescue. Add scalability to your architecture by using services such as virtual machine scale sets. So in other words, we will discuss in detail about virtual machine scale sets, but what are they? They will allow us to scale our application automatically. As the load increases, these scale sets will allow us to scale. They will allow us to increase the number of servers or the virtual machines, and we will be able to handle any amount of data. Add disaster recovery by using backup and recovery services. Imagine disaster recovery is extreme conditions where there's a lot of floods and natural calamities, and what happens is the company is down and the data is gone and everything is gone. What do? You need to handle, you need to be ready. In cloud computing, they take care of all these things. All the infrastructure is taken care of by them. We don't need to buy or maintain any special kind of infrastructure for that kind of things, guys. Okay, everybody okay with this slide? Okay, again, that's a brief introduction or a quick introduction, guys. We'll go deep into these things in a moment. So there are three kinds of different cloud models. One is public cloud, another one is hybrid cloud, another one is private cloud. So let's start with public cloud. Examples are cloud service providers such as Microsoft Azure. Microsoft Azure is a complete cloud service provider. We can almost get any kind of infrastructure we can in the cloud, guys. The physical infrastructure is managed by Microsoft. In other words, Microsoft is taking care of the complete networking. All you do is you just make sure you have a browser available and you're able to run access the internet, and they can set up your entire company virtually. The IT part, the digital part of your company can be set up on the cloud. And what does Microsoft doing? Microsoft is taking care of the entire physical infrastructure. Behind the scenes, what companies like Microsoft, Amazon, and Google, all these cloud service providers have is, around the world, they have these huge data centers. They have thousands and thousands of servers and acres of land, in 50 to 100 acres, maybe 1,000 acres of land. They build this infrastructure, they keep them ready. Using this infrastructure, they're able to provide different kinds of services, guys, okay? How? We'll try to understand. You have access to various services offered by the cloud provider. What are they? Whether you want to build a web application, a web service, or any other kind of thing in your company, it can be done on the cloud. You can access the various services by using a web browser. In other words, you just need a web browser. As simple as that. You don't buy any software, you don't buy any additional hardware or any additional software. Just using a web browser, you'll be able to build your IT applications, build your other build your applications and IT related things, guys, okay? The advantage is it lowers the cost and less maintenance because we are just focusing. Imagine if you're a cricket player, you just want to focus on the batting, bowling, fielding, wicket keeping. You don't want to build we are not interested in building the stadium. We're not interested in building the seats and maybe the playground. What do we do? As a cricket player, you should focus on batting and bowling. That is what is important. But as a cricket player, if I'm asking you to come and first build the stadium to play the game, then that is not right. There's a lot of time which goes in there that is not really required for cricket. So what is happening? The stadium is like the Microsoft. What are they doing? They're giving us many resources, the playground, the seats, the chairs, the wickets, and everything. What is that? All that is infrastructure. What do? You just come in and do batting and bowling. Okay. You don't have to build the stadium. You don't have to own the stadium. What is that? You don't have to. If you have to build a stadium and own the stadium to play cricket, then that is a lot of money. Because we don't have to build the stadium and own the stadium, we are saving a lot of money. High availability and reliability. In real world, enterprise applications need high availability. In other words, they imagine Harika is accessing her data, her Facebook page, and suddenly the Facebook is unable to fetch the data. Behind the scenes, what Facebook does is, since Niharika is based out of India, first it will try to access the data from a data center which is closest to India. Maybe if for some reason she is not able to, they are not able to access the data of Harika from Indian data center, they will try to access the closest data center, which is maybe Australia. If that is not possible, then they will try to access the data from USA. What is this? This is high availability. In other words, at a slightly cloud level, at a data center level, they're replicating the data. Whatever Harika's data is there on Facebook, it is not just there in one data center, but they're replicating across multiple data centers. In an enterprise business scenario, making the data not available or unavailable is not acceptable. Okay, so what do? They replicate that one. And what is that? That is high availability. And what do? They use very expensive hardware, so the reliability is high. Okay, what is this? That is public cloud. It reduces the cost and the maintenance is what it is, guys. Okay, imagine okay, let's also go into the private cloud and let's come back here, guys. Here is private cloud. Here the infrastructure is managed by your company. In other words, sometimes what we need is, we just need the playground, and what we would like to do is, we would like to design the stadium. We would like to get our own infrastructure, the seats, maybe the wickets, all the other things which are required. What is it? That is the infrastructure which is owned by us. What is happening? Oh, my bad. Let me put it in another way, guys. Private cloud is infrastructure is managed by your company. That's what we just said. This is when the company wants to own the entire infrastructure. And when is that? Well, government agency or a financial institution. What happens in a government agency is, you have data which is related to the public, and government may save some very confidential information about the public, and they don't want others to have access to it. So what do? We need to save it in our own infrastructure, in our own web service and things like that. That is a scenario where we want the infrastructure to be private. Public is something where anybody can access it in its pure meaning, but private is not everybody can access it. They want to own the infrastructure and the data. So even in financial institutions, your credit card numbers, your logins, passwords, they are very, very confidential. We don't want this to be available on the net, or we just don't want the risk of it to be available on the net and accessing on the internet, because there is a chance that others might hack in and things like that. You would need to invest in that infrastructure. So you want, we need to buy the infrastructure, is what it is. Okay, and let's see. Okay, I'll see if I can simplify it, guys. Okay, stick with me. So here is hybrid cloud. Hybrid cloud is a combination of public and private cloud. So on-premise servers is a group of servers that we have. This is our own infrastructure where we store or save our own data. Now, what we would do is, we want to use our own on-premise servers and also use some of the capabilities of the cloud. What is that? That is called hybrid, because it is a mixture of public and private. We connect Azure to our own on-premise infrastructure. In other words, we are using Azure and on-premise infrastructure. There's a mix of both of them. That is called hybrid. We are trying to get the best of from both sides. Anything which is private, we will keep. Any data which is private, we will keep on our own servers. Any data which doesn't need to be private, which is okay to put on the internet, we will try to use the cloud. If we can migrate our current workloads to the cloud. So some current workload means some of the work that we do, we cannot do it on the cloud. We cannot execute on the cloud. We should not access it on the cloud. Those are the things we'll put it on our servers. So what is it? There is a lot of flexibility. We are able to do both of them. but there are additional costs and maintenance because we are we have to maintain our own servers, our own infrastructure and things like that. As a result of that, we have on-premise additional costs and maintenance, guys. Okay. So let's say, okay, let's one more time come back here. Public cloud, guys. Okay. So imagine one moment, guys. I'm trying to simplify this one for you. I'm trying to come up with a. Okay, let's try this one. Say I'll annotate this. This will probably not work. May close this one. Or to stop the share. Share it again. And let's say come back here. Okay, let's see if you can understand this one, guys. Imagine here's a building. And in this building, what we would like to do is we would like to set up a coffee shop. Now, this is a coffee shop where a lot of people will be coming in, a lot of public will be coming in, and they'll be drinking coffee, they'll be going back. And what do? Well, we make money out of the coffee. So it is accessible to the public is what is public cloud. Okay, but let's take another building for sake of simplicity. Start with, let's say this one. Or in other words, let's come back here, choose this one, choose this one. So here is another coffee shop. This one is not open to the public. This one is private. It is only for a group of, let's say, premium customers and things like that, who are our clients and things like that. And it is only available. So you can think of that as a private coffee shop. Then comes the hybrid where we need a mix of both of them. So let's say for sake of simplicity, take this one. This is where we are expecting a few premium customers coming to us and a few public. It is open to some of them who are public, not everybody. Is one way to think of it or visualize that, guys. Okay, let me see. So, okay, to start with, it is there, guys. Okay, now let's say back to choose this one. Here is a building, back to a coffee shop. And what is happening in a cloud computing model is now notice as a coffee shop company, we are good at making coffee. Okay, but in order to run a coffee shop, some of the things that we need is, let's say, we need electricity. Okay, but what do? Well, electricity in order to, because we need electricity to run our coffee shop, what we do is we go to a electricity service provider. So there's an electricity service provider. And what do? Well, they generate the electricity. And what we are doing is we are getting the electricity from there. And we are using it in our coffee shop to make the coffee. Okay, so now imagine a scenario where we needed to set up a, so I come here, choose this one. Imagine as a coffee shop, we needed to set up the entire electricity department. What is that? That is what is happening. The coffee shop is the IT company. And today, buying their infrastructure, IT services, and other kinds of software and hardware is the process of setting up the entire electricity company. One moment, there you go. Okay, so back to the IT company. Similar to external private data, like office canteen versus cafe day. Okay, good one there. Pravalika, you can send a message to everyone so that everybody is looking at your answers. See, yeah. Okay, so that is the story of the coffee shop, guys. So what is happening is, because the coffee shop, imagine in the building is the guy where they're like the Microsoft, the cloud service provider. What they're doing is they're providing all kinds of services, all other kinds of services except coffee. Only setting up the coffee, selling the coffee is what we are doing. The electricity, the other kinds of infrastructure which are needed inside a company are being provided by the building, and they are nothing but the Microsoft Azure guys. Okay, so as a result of that, if we are not setting up a building, we're not setting up an electricity department, all the resources, different kinds of resources needed to run the building in order to run the coffee shop. What is happening? All that investment we are saving. Everybody catching it, guys? Quick yes, please. Okay, now one more time. Let's stop this one. Back here. Okay. So now let's come back here. And let us see. Let me share this one. Have to sketch. Back here. Say share. Select this one. Okay. Now let's see what is happening here, guys. Back to public cloud. So what is public cloud? Examples are cloud service providers such as Microsoft Azure. So Microsoft Azure is a big building which is giving different kinds of services. They are taking care of the electricity department also. You don't worry about that. Electricity and other kinds of things, the laundry, the whatever is needed in that one. They're also giving you the infrastructure and everything to run the coffee shop. Not only we can set up a coffee shop, but there are different kinds of businesses. So what is happening in this building is, there is not only a coffee store, but there is also a restaurant, different kinds of restaurant, there is games, there is other kinds of things going on. It is for public, everybody is using it, so it is public building. Okay, the physical, again, the infrastructure is managed by the building, which is Microsoft. We have access to various services offered by the cloud provider, that is, the cloud is providing different kinds of services. And oops, one moment. Okay, sorry about that, guys. So we are using a web browser. In other words, if we map our example to the coffee shop, what does it mean by using a web browser is, imagine we are able to set up a coffee shop using a browser. For the sake of simplicity, we are able to take care of everything. What's happening? Lower cost, less maintenance is, again, we saved a lot of money. We don't have to buy the building. We don't have to own the building. And high availability and reliability. So in other words, let's say you're in a coffee store, and say you're in a coffee store, and let's say the electricity goes down. Or in other words, the restrooms are not working. What's happening? Well, you don't worry about it. You don't take care of it. That is taken care of by the building owner, which is the cloud service provider, which is nothing but the Microsoft Azure. So they are taking care in case something goes wrong. In case there's a problem in the electricity, they own a generator, they will be bringing it home. And so it is reliable. Not only, so if there's some problem in the restrooms, what are they doing? They're immediately making somebody available. They are taking care of that. We don't do that. Otherwise, generally, what do? We will have to own somebody and maintain, pay and own somebody, guys. Everybody with me? Quick yes, please. Okay, let's say come back here. Next, from a private cloud standpoint, so the physical infrastructure is managed by our company. So what is a private cloud is, imagine a coffee shop where you're telling, so in a coffee shop, so back to the public cloud, what we told the building owner is, hey buddy, you give us all the infrastructure, you give us the coffee machine, all we will do is we will just run the coffee store. And you take care of giving all the chairs, all the coffee machines, and different kinds of things. All we will do is we will come in, we will make different kinds of coffee and sell it. Whereas a private cloud is, you are asking the building owner, just give us the room, we will get our own infrastructure. So what's happening is, we are owning the infrastructure of the coffee company. In public scenario, in public cloud scenario, we rented it from the building owner. Whereas here, we are getting our own. We don't want to use yours. We want to use ours, because ours is patented, ours is special kind of things. We have some very confidential things and so on. So the entire coffee shop infrastructure is owned by us. Okay. And as I said, the data could be confidential in such cases. What we will do is we will not store the data in public servers, but we will save in our own service is what it means. So what do we do? Well, we will need to put some money into buying our own infrastructure. That is where we spend money. That is what is private cloud. Quick yes, please. Okay. Next is hybrid cloud, where we are saying we are using a combination of both of them. We're going to be taking a room in that building. We're going to be using some resources of the coffee shop from the building. Let's say, for the sake of simplicity, to run a coffee shop, we need a coffee machine only. The rest of all the things will be coffee machine, except for the coffee machine, which we will be bringing in. Rest of all of them will be, so we'll be renting it from the building owner. What is that? Well, that's flexibility, as simple as that. Everybody catching it, guys? Quick yes, please. So there are additional costs involved here. What are the additional costs? Additional cost means, again, we have to buy a coffee machine and we have to maintain it. We have to take care of it. We are getting the best of the both sides. We are trying to lower our costs by using as much as we can from the cloud. At the same time, we are also making sure our data and anything confidential is within our company on our own, on things on our own infrastructure. That is a hybrid, where it has a combination of both public and private. Quick yes, please. Okay, let's see what else we have. So next one is infrastructure as service. Let's see what are the different kinds of services in cloud. Here the physical server is managed by the Azure. So the server is managed by the Azure. Generally, we rent out a server. What is server? Server is an infrastructure. What we are doing is, as a service means you're renting it. Imagine the coffee shop is getting the electricity. Okay. So all the bulbs and things like that is also an infrastructure. Is managed by the Azure, means managed by the building. There, the building owner is saying, hey, I will give you all the lights, I will give you all the ACs, I'll give you all those things which are needed from an electricity standpoint. You don't need to manage the various aspects of the physical server. In other words, all these infrastructural things, you leave it to me. You just run your business. You only manage the virtual server. So virtual server is, imagine in our building, let's say, come back here. Back here, let's say snap this one. Back here. Okay, imagine this is our building. In this building, let us say we took, let's say for sake of simplicity, let me do this. Let me move this here. This is a complete building. Oops. Let's say there are 2 floors here. This is the first floor. Let's say this is the ground floor. Now what we are doing is, we have to run our business. What we want to do is, we want to set up one coffee shop. Let's say here is a coffee shop. We also want to set up a separate restaurant. For the sake of simplicity, let's say here's a restaurant. So what is this one? This one, in this building, we have taken a floor. That floor is like a physical server. Oops. This here. It's like a physical server. In that one, you can have multiple businesses. What is this? Each business is like a virtual machine. Is what it is. You can set up a coffee shop. You can set up a restaurant, maybe a gaming shop, or whatever you want, and other kinds of businesses. Okay. So the physical server is like a part of the building. And you don't need to manage the various aspects. So in other words, the room, the entire first floor is being taken care of by the building owner. You only manage the virtual server. Virtual server is your business. How to run a coffee shop is your business. How to run a restaurant is your business. Allows you to quickly provision environments and also terminate them. So at any point of time, let's say your coffee shop is running fine, whereas the restaurant is not running fine. What do you want to do? You want to get out of the restaurant business. What do? You just want to manage the run and the coffee store. We're able to. We can also do that whenever they are not required or whenever they're not doing fine and things like that. And what happens is behind the scenes, we save a lot of money because of that. How? Let's try to understand. So what is that? Again, infrastructure as a service. So what is happening here is no capital expenditure. What is capital expenditure? Well, I didn't have to build a building. I didn't have to build a first floor or ground floor and other kinds of components of that building. Then reduces the operating expense. Operating expense is how much you're spending to operate your business. What are the electricity costs? What are the different kinds of costs which we are incurring on a monthly basis, on a daily basis? All those things, they are reduced. We will have operating costs. We will not have any capital expenditure. We'll talk in detail about them in a moment. You can focus on what's important for your business. You're a coffee shop where you focus on coffee shop. You don't focus on the construction. You don't focus on the electricity. You don't focus on the laundry and the janitors and the other things. Okay, then you can get access to various computing types. Okay, the various computing types we'll discuss, the computing types, resources, and things like that. You can host various types of workloads on virtual machines. So again, this is a coffee shop. This is one kind of work. Running a restaurant is another kind of work. If you want, instead of a restaurant, maybe tomorrow you would like to do something else. You'd like to open a theater. You can do any kind of thing is what that means, guys. Okay, various kinds of workloads on virtual machines. So that is infrastructure as service. What is happening is, so I come back here. What is infrastructure? The building, the room, except for your business. Everything else is what is being rented. All the infrastructure is given by them, is what is infrastructure as a service. All the infrastructure is taken care of or is given by the cloud service provider, guys. Okay, now let's come back here. Here is platform as service. Let's see. Here, the physical server is managed by Azure. Again, the same as infrastructure as service. Even the virtual machines are managed by the Azure. What is virtual machine? Let's say if we come back to our example, virtual machine is a coffee store or a coffee shop is what we said. Or in other words, more precisely, here is coffee. Let me see if I can do a little bit of cleanup here. Okay, here is the first floor. Here is the coffee store. Here is, let's say, the restaurant. Oops. Here's the restaurant. Let's say choose this one. Come here. I'll put this here. What is this one? This is room 1. This is room 2. Part of the building. And let's say this is room 3, room 4. Now in each room, we are running a different kind of business. There's a coffee. The virtual machines are managed by the Azure. Means think of virtual machine as a room inside the entire first floor. Okay, the room is managed by the building owner. What you do inside, whether it's a coffee shop or a restaurant, you're running a restaurant, is up to you. So the virtual machine is like the room. Even that is taken care of by the machine. Even some systems are automatically set up for you. So let's say you tell him, hey buddy, I need a coffee. He's coming and setting up the coffee machine, the chairs and things like that. So some of those infrastructure is also being provided by him. Okay, then data example. So this is at a slightly logical level, a simple, friendly mantra. Now, if you come, if you take a look at the technical mantra, here is database management system. What happens, guys? Azure SQL database or any kind of database. When we use Azure SQL database, we don't have to buy the software. We don't have to worry about installing it, buying a server, installing it, licensing costs and things like that. You leave it to the Microsoft or the building owner. Allows you to host a database in the Azure. So in other words, they are giving you the SQL database. And what you do, you insert the data, you save the data, you retrieve the data, you analyze the data, you try to understand some useful insights. So what is happening? What is SQL database? It's an application. Okay. Here, the database management system is managed on the Azure. Again, the database in your coffee shop, imagine we are using a database. The database is also being given by the building owner. He's saying, I'm also going to give you the database. You can use my database, store your customers' data. Okay. And that also he's taking care of it. He will store. You don't worry. You just enter the data. Gives features such as automatic high availability. What is the problem? If you buy a separate database from some other place rather than this building owner, that if there is a bug or some problem in the database, what will happen is your database might be down, and you will not be able to work with your customer data or customers. So here the building owner is saying, don't worry. We are giving you a database which will not only work for you, but we're giving high availability. At any point of time, if there is any problem in one of the database parts of it, we will automatically make another one available for you. Gives us automated backups. They are only taking care of the backups. In other words, these are the things we need to do as a coffee shop. You need to create a database. You need to store the data. You need to make sure you're maintaining a separate server. You need to make sure you're doing the backup of the data periodically. What is it? That's what he's removing from you. Remember, your mantra is, if you're a cricket player, focus on batting and bowling. Don't focus on the stadium or the chairs and things like that. Catching it, guys. So in other words, back to our coffee shop, not only now all the things we are renting, but he's also giving us a database. That is what is platform as a service. Catching the point, guys. Quick yes, please. Okay, next one is software as service. In addition to the platform as a service, the software is installed and managed for you. So again, back to the database. Now, platform as a service, what is about database, guys? On database, you can write custom queries. Okay, it's a platform service. Whenever we have a database, so what is that? That is custom development. You can also do custom development. But when you come to software as a service, in addition to the platform as a service, the software is installed and managed for you. So in other words, they are providing the application. This time, database they have given you, that is an example of platform as service. Now they are saying they're going to give you Gmail, Word, and things like that. So what is it? When you use Gmail, Word, and PowerPoint, you don't write custom queries. You just use their service. They're giving you the software. In platform, there was one additional, that was like a power user. You're also able to write custom. In Gmail and Word, you don't write custom queries. They'll just give you the software. What features they gave you, they're already developed for you. If you want to develop a custom feature, you may not be able to develop. In platform as a service, you'll be able to develop is what it means. We'll be able to write our own queries. So what is this one? Your Gmail, all these things that we are using on the web, Yahoo Mail or other kinds of Google products. This is software as service. They're taking care of the infrastructure, they're taking care of the platform, and they're giving you the software. So in other words, let's say if we put it back to our coffee shop, we are renting the building, we are renting the room, we are renting the other kinds of components. That is all infrastructure. Platform is where that guy said, hey, I'm going to give you a database, you can write custom queries. And then he's saying, you don't use Gmail, I'll give you my mail. I'll give you my office. Everything is available for you, that you generally pay money. Let's say we are paying money for Gmail. Let's say we are paying money for other components. He's saying, no, I'm going to give that. You just pay me rent. You just use them. You don't have to write queries in Gmail. Of course, we can write really if we want to, but ideally, most of the time we don't write queries. Okay, so the database is where we definitely write queries. As a coffee shop owner, you'd like to understand all your customers, where they're coming from. You'd like to analyze the data. Whereas when you use Gmail and things like that, you don't analyze the data like that. You just use send email, receive emails, send the orders, check the orders, and things like that. Catching the point, guys? Quick yes, please. Cool. Gentlemen, ladies, are you catching the point? Okay, so now what is expenditure? Expenditure is nothing but expenses. Traditionally, as a coffee shop, imagine you have to buy a web server, you have to buy a database server. People who sell coffee know how to make coffee, but they don't have any hardware or software experience. Expecting them to learn all the software and the hardware to make a coffee is not right, is not a good idea, guys. Okay, so what do? That is the kind of expenses that we will generally incur. What do? Well, imagine the cloud was not there. We need to pay the money for the servers, for the storage, for the software license, for the hardware license, for the database license, for the networking people and everything. What's happening? Well, that is called capital expenditure. To get started with a coffee shop, you need to play cricket. You buy a stadium, build the stadium, build the chairs, and then only you'll be able to do batting and bowling. So before you do the batting and bowling, you're putting a lot of money. That is called capital expenditure. Quickest place. Okay, so what is operating expenditure? Operating expenditure is what is the rents you are paying on a monthly basis. You pay rent for electricity, you pay rent for water, maybe other kinds of utilities. What is that? That is operating expenditure. You pay for workforce. You pay your players. That is operational expenditure, is what it is. So what is happening? We are saving a lot of capital expenditure. Let's say you have to say the capital expenditure is $1 million. What is that? To set up a coffee shop, you're saving right away. And let's say every month you're spending maybe $1,000 or $10,000. That is the only cost you're incurring. Okay, so what is the advantage? You can practically have no capital expenditure. Whether it is $1 million to build a stadium or maybe a coffee shop, all that money we are saving. We are not buying servers. We don't have to worry. We don't have to learn about the servers. When it comes to the operating expenditure, you only pay for running cost. In other words, let's say Niharika owns a coffee shop. And let's say Vinay also is owning that coffee shop for the sake of simplicity. Niharika says, on a daily basis, I will only run in the mornings. During afternoons and evenings, I don't want to run. So that during afternoons and evenings, let's say Vinay is taking up the coffee shop. So if Niharika is only using it for 4 hours, she's only paying for 4 hours. She's out there. She's not paying for the rest of the 20 hours or whatever the time she uses. Okay, so what is that? That is what is called pay as you go. You pay only for what you're using. You don't have to pay higher. You can terminate the resources whenever you don't require them. So as I said, if you go back to our example, we had a coffee shop and a restaurant. Suddenly we realized the restaurant is not working well. The coffee is going good. So what do we do? Well, let's get out of the restaurant business. So what will happen? Well, all the capital expenditure we would have incurred would be saved now. Okay, so you can terminate the resources whenever you don't require them, whether it is individual resources or a complete thing is what it is. That is another advantage, guys. Okay, everybody with me? Quick yes, please. Okay, now here comes what is called the shared responsibility model. Understanding responsibilities between the customer and the Azure. Customer is us, let's say, who are the companies and the businesses like that. Azure is the Microsoft cloud service provider or Azure cloud service provider. What is shared responsibility model? When we have resources deployed to an on-premise data center, you are responsible for the entire setup. In other words, you're saying, let's say, come back to the coffee shop, you're telling, let's say you give, here is a coffee shop and that is our room. Now, let's say, come back here. Now in the coffee shop, let's say, there is this very highly confidential area. For this area, let's say this is indicating the coffee shop. This is a room inside the coffee shop. Now what you're telling is this is the area which you want to manage. You want to manage explicitly. That's your golden room. That's where you have your money, your gold, and things like that for the sake of simplicity. You don't want anybody to enter. So what you're saying, that is what is shared responsibility. The rest of the thing is being shared by the building owner. The center part, the golden part of it is being taken care of by you. When you have resources deployed on data center, you're responsible. So you're saying you're going to take care of that. You will be responsible for the entire setup of that golden row. The infrastructure, the server, storage, maintenance, security of the data centers In other words, whatever is inside that golden room, you will take care, whether that is hardware or software. You will take care of the security. You will not let the cloud come into your picture. And who will come in, who will go out also will be taken care of by you. When you start moving to the cloud, when it comes to Azure, Azure takes a set of responsibilities. So in other words, let's say you decided, okay, you've taken all the gold out of it. Now what you want to do is, okay, you're saying, hey, I'm going to go cloud. What is happening now? You're giving up your responsibilities and leaving it. But now, what are we doing? We want that to be very private. So part of it is very private and is taken care of by us. And the remaining part of the room and the building is continue to be owned by the big guy who is our cloud service provider. So we are sharing. It is important to understand the line of responsibilities. When you tell the cloud service provider, these are some of the things that you can do or you cannot do, we need to be very, very careful. We don't want to give confidential data and at the same time vice versa. It helps you plan on what tasks you need to carry out when you have resources deployed to the Azure. So again, we have to be very, very careful. We are sharing the responsibility with the cloud service provider is what is going on, guys. Okay. So responsibility transfers to cloud provider, varies by service type, always retained by customer. There are different scenarios. The shared responsibility model will work at a physical level, at a software level, at a component level, and things like that. That's just a quick picture. But let's get a little bit deep into it. When you create an Azure virtual machine, Azure is responsible for the uptime of the service. So what is a virtual machine, guys? A virtual machine is like a small room in the first floor or the ground floor. Inside that virtual machine, what do? We have different kinds of applications running. One is a coffee application, another one is a restaurant application. What is that? That's a coffee business and a restaurant business. What do? We are taking a first floor or a ground floor, and in that one, we want to run multiple businesses. Each business is like an application. So Azure is responsible for the uptime of the service, means Azure is taking care of the building, the room, the building and the room, the building, the floor and the room. That is infrastructure. They're continuing. It is responsible for the physical infrastructure. Azure is responsible for various aspects in the data center, cooling and security, cooling, security, electricity, the air conditions, all those things are also being taken care. That was also infrastructure. Customer is responsible for operating system level patching. So now what is happening is, in this golden room that we have, what is that one there? We said, I don't want anybody to come in and I want to be taken care of that one. What we are saying is, we need to keep that room up to date. We cannot, because we are taking care of it. If you don't cool it or if you don't maintain the proper temperature, what is going to happen is, well, the environment might not be good in that room. So what we are doing is we're sharing the responsibility. We are going to do part of the responsibility. Customer is responsible for the applications and data hosted on the virtual machine. Means, remember, each application is one business. I will give you the room. The building owner is saying, I will give you the room. Whether you run a coffee shop or a restaurant is up to you. Whether you will run Microsoft Word or maybe its competitor is up to you, is what it means. Everybody catching that, guys? Quick yes, please. Okay, so let's say understanding the core services, and let's say, okay, before we go into a little bit of lab and things like that, give me one moment. Let me check and see if I have any response from our support. See back here. It's fixed. Okay, great. One moment.
We have meeting at 4:30, sir.
Okay. Okay, guys. Everybody, yeah? Everybody has a meeting?
Yes, sir.
I see. I'll leave you. Is it okay if I take till 4:30, guys? I mean, at least I'll give you 5 minutes time, but is it okay? Everybody okay with that? Let's see where we are. Okay, let me see if I can give you a simple task. Back to the host. I come back here. Let's say tab this one. I'm looking at Cloud Labs, right? Cloud Labs. Oh no. Here we go. This is not saying the password. What is this one? It's the password. I need to go back here. Oh, here we go. It's the Firefox. Say refresh this one. Access denied. Take me home. Go to dashboard. What is my password? One moment, guys. I'll just see if I can show you a quick demo and leave you. The password. Oh, what's happening here? Copy this. Okay. This video. Save it. Invalid credentials. So, okay, there you go. Let me say view lab. Azure console lab. Something is not right here. Show what I'm doing here so that you just have an idea. Problem I'm facing. May come back here. Share the screen. So I'm sharing the screen. There it is. Back here. So I logged into Azure console lab. You guys can also log in, guys. And it's coming like this. It's not giving me. Earlier, there used to be a button where we used to start the lab, and then we were able to access Azure portal and things like that, guys. Okay, that is not coming up here. So that's what I'm going to stop it again. Go down. One minute, guys. Okay, there you go. Send the message. Back to see if I can give you regions. Availability zones. Okay, let me cover a few things and I'll leave you for today. Say, share the screen. Where is that? This one. Share it. Okay, core services and things like that. Okay, regions and things like that, guys. Let's try to understand what is regions and things like that. And in the coming up days, since this is the starting, I'm just introducing you a few terms. In the coming up days, we'll dig a little bit deep into it and you'll get a good idea of it, guys. Okay, we'll be preparing for AZ 900 course here, and I'll be giving you more details once I give you a little bit of introduction. So some common terms, let me introduce you. What is region? Azure regions. Azure have regions across the world which can be used to host resources. Okay, so in other words, let's say, for sake of simplicity, I guess let's go back to my coffee shop here. Stop the share. Share this again. Okay, back to the coffee shop. What is happening is, back here, we have regions across the world. Means imagine the building owner is also telling, hey, if you would like to, the same coffee shop you can also set up in different parts of the world. I'm going to give you access. What business you do, you can also do it in other parts of the world. That is, what is this? He's giving access to different regions, different continents. Regions are like continents. These are different geographic locations situated across the world. You can host resources in Azure in any one of the available regions. Let's say you have a lot of, let's say we are based in India. We have a lot of customers coming from India, and Indians like Indian coffee rather than any other coffees of the world. Indian coffee flavor, Indian tea flavor is much different from the rest of the teas and coffees. So what do we do? Since most of our customers are going to come from India, we want our coffee to be available in all the major cities, coffee shops to be available in the major cities of the in India first. In US, in Australia and UK, there are less number of customers coming. So there, maybe I need just 111. Whereas in India, almost every major city, I want to set up one business. What is that? That's what this means. In other words, the building owner is also giving, I'll give you multiple buildings. I can give you multiple buildings where you can set up your businesses is what it is. That is what is a region. What is a region? At a slightly high level, you think of region like a geographical continent. Quick yes, please.
Sir, you can take class up to 5, sir.
Oh, I can. Okay. Okay. Great. Thank you. Good, guys, because that's slightly, I don't know if I have any control on that, but sorry about that. Okay. So let's see. So what happened to your thing? What happened to your meeting? Is it cancelled or something?
No, it is not from Savitri ma'am and Swati. It is different from Shritika Chaudhary, it seems.
Oh.
So leadership sessions. So.
Oh, okay. Thank you, Subbu.
Thank you, sir.
Thank you. So, okay. So there's a data center, guys. If you go back to the world of big data, a rack is a group of servers, a group of racks is a cluster, a group of clusters is a data center. A group of data centers is generally the cloud computing model. When we create resources in Azure, they're created in the underlying data center. What is a data center? A data center is like a group of buildings. Itself can be thought of as a data center. A cluster can be thought of as a building. Inside that building, there are different kinds of big rooms. The big rooms or each floor can be thought of as one rack. Inside the rack, inside the floor, you can have multiple shops. Each shop is one server. Or as a room inside the room, they can again be multiple subrooms is what it is. So Azure is responsible for maintaining all the buildings, which is the data center. The data center contains all the physical infrastructure required to host resources in the Azure. In other words, the cloud service provider is taking care of all the infrastructure one more time, whether it is a room, building a small room, a big room, a bathroom, or a kitchen, everything is being taken care and provided by the cloud, the building owner, who is the cloud service provider, guys. Okay. Now, there are different centers, data centers. So what he's saying is, hey, you're using my coffee shop, let's say in Hyderabad or maybe Mumbai. You're using my database. What he's saying is, as you save the data in your coffee shop in Hyderabad or Mumbai, he's also replicating the data across multiple. Just in case, behind the scenes, when you are using our database or maybe our application, our Gmail application, you are not able to retrieve the data, that is not your problem. Behind the scenes, we will take care of it. We will get it from another one. What are they doing? They're internally saving our data to different data centers. They're maintaining, they're replicating the data into regions and availability zones. They are taking care of these regions, geographical locations. Each region consists of multiple data centers that are connected by a low latency links. Means these data centers, low latency means low delay, which means they're very fast, they're quick, they're very highly connected, so that there is less time taken by the application to process or maybe analyze and things like that. Everybody with me, guys? Quick yes, please. Okay, availability zones. Now, there is something called availability zones. These are physically separate locations within an Azure region. So let's say we have a coffee shop in Hyderabad. What the building owner is doing is our data, the coffee shop, the Starbucks coffee shop data, which is in Hyderabad, he is maintaining another building just in Hyderabad as a backup. For the sake of simplicity, for building one, there is a building one backup. So any data that we enter in Starbucks coffee, which is in, let's say in Hyderabad, he is in building one, he's storing in building one backup, which is in Hyderabad only. He can also save it to US, UK, or maybe Australia. But what is he doing? He is giving an availability zone. There are physically separate locations within a Azure region. Building 1, building 2 are separate. Each availability zone is made of 1 or more data centers. Each building has again more buildings inside it, more small buildings inside it, and more small buildings have more rooms and things like that. Each is equipped with independent power, cooling, and networking. All these buildings are also independently connected, which means if there is a power cut in one building, it doesn't mean there will be a power cut in building 2. There might be, they're independent of each other, and all their infrastructure is also independent. You can use availability zones to run mission critical applications with high availability and low latency. What is mission critical? That is what most of the business enterprise applications are mission critical. They do not want their data to be down at any point of time because they're doing some heavy processing, some premium processing, important things and things like that. It's like you're a coffee shop where you're saying you have very, very important people coming in to meet, they're having their discussions and things like that. You're serving coffee. At any point of time, you don't want a power cut, you don't want any kind of interruption. That is mission critical. If there is any problem as a coffee shop owner, you don't want to, you don't want, first of all, and you don't want to take care of it. What is happening? The building owner is saying, if there's any problem, you don't take care, I'll come and take care. That is mission critical. High availability. They're always available if there's any problem. Low latency, delay, less delay. If there's a problem in your restroom, you're going and looking for finding a guy who will fix the restrooms or the bathrooms. That will take a lot of time. The building owner is maintaining a group of guys who are immediately available, highly available, and they come immediately. They're taking less time. Catching it, guys. Okay, so these are some of the Azure regions and things like that. There are totally 54 regions in 140 countries. And we have regions, we have availability zones. Within a region, there are different kinds of availability zones. We'll see what it is. So here is, let's say, let me come back here. Where is this one? So back here, guys. Let me see if I can do a refresh here. There used to be a lab, if I click on lab, it used to take me here. Now it is not taking me where we used to access all our resources, but let me come back here. So what we can do is, let me see if I'm able to access this one. Give me one moment, say stop the share. Okay, still waiting for them to come back. And let me see where is my stuff. Create a virtual machine. Okay, let's close, go here, go here. Okay, so let me share the screen. Sharing the screen again. So here we go. This is where whatever screen I think. Click on OK. So the first thing I did was 17 to portal.azure.com. And we'll need to log in here. For now, for today, we'll do this. Hopefully by tomorrow, our this thing will be up and running, guys. Okay. So I went ahead and logged in. Once I logged in, this is where I am. We'll one more time, almost on a daily basis, we'll be touching the labs and things like that. We'll try to get familiar. These are the different kinds of resources and services which are available. We create a resource, virtual machines, machine learning, and there are other groups. Other kinds of services, Kubernetes. We'll get an idea for each of these things. We need to have an idea for Azure 900 certification. Yes, that's what our objective and goal is going to be. So that's what we'll be working. These are more services if you want to. There are tens and tens of services. Retraining, virtual networks. We will create virtual networks. We need to understand what is the cost and things like that. And so on. So here is all services. So on the left-hand side also, there are different kinds of services, Kubernetes, Docker, DevOps, and things like that. Citrix disks, you want to add the virtual machine. Sometimes you want to add the disk to them. Sometimes you want to add the RAM, the speed, and different kinds of things, the containers. That is what we'll try to get an idea in the coming up days, guys. Okay, so let me come back here and see what I have here. Okay, back to the PowerPoint. So ideally, when you log into, you'll get 12 months free account. And there is a 12 months free services, $200 to explore any Azure services for 30 days. For additional 30 days, for about 200 credit. So they will give you $200 additional. For 30 days, you can use the additional services. Okay. For us, we will use the lab. We will not log in and will not use it right away unless it is really necessary. About 25 plus services are always free. These are the kind of, they're not the basic, but they are like the basic to medium services. If you need some more specialized services, that's when we need to pay. But these 25 plus services are always free. Not just the 12 months is what it is. What we would be using is, we will be using Windows virtual machines, we'll be using Linux virtual machines. They are 750 hours free. Create Windows virtual machines on demand. This is the model or the type of the machines which will be available for us, virtual machines, which will be available for us, guys. Okay. And I will try to explain you what is a virtual machine in a moment. And these are the blob storage, file storage, SQL database. These are the different kinds of storages we'll be talking, different kinds of database. So they give us up to 250 GB database and Cosmos 5 GB. And then we can build various kinds of web services. We can write Lambda functions using Azure functions. Face API, this is the machine learning, AI and machine learning. We'll give a touch of all these things, guys, okay? So these, whatever is free is freely, they are listing it here. So here is a quick FAQ. Do I pay anything? The same thing is explained. What happens after I use my 200 credit or 30 days, or you can upgrade to a pay as you go. Initially will be in a fee subscription model, then pay as you go. Pardon me. Is where we will pay as much as we use. That is called pay as you go. For electricity, whether it is our home or business, we'll not set up an electricity company, guys. We will pay as much as we use. If you're using only 1 hour a day, you'll pay only 1 hour a day. That is called pay as you go. Okay. So again, they would need a phone number and a credit card if we were to sign up manually. But for us, they will, since we have the labs, hopefully we should be able to get in without really phone number and credit card things and so on, guys. Okay. So here is stop the share. And let's say share this, bring up my portal, all services. So I will share this one. Say share this one. Here is all services. Let's say share. So today what we'll try to do is we'll try to create a simple virtual machine. And for that, what we're doing is we can filter also. You can come here. You can say virtual machines. Pardon me. Sorry about that. So you click on virtual machine and brings up various things here. What we want to do is we are looking for a create. So there is create. Click on create virtual machine. First, we'll create a generic virtual machine, something with minimal stuff on it. And now it gives the different things. So pay as you go. Let me see. Okay. So here, it's giving pay as you go resource group. Okay. We'll try to create a new resource group. I'll try to explain what is a resource group. Resource group is nothing but a group of resources that we are logically putting together that we will commonly use again and again in the coming updates, guys. Okay. We'll go into the depth of resource group maybe tomorrow and try to understand a little bit. But let's say, we'll say RG1, resource group 1. For sake of simplicity, click on OK. That's our resource group. Virtual machine, you can give any name, let's say VM1. And let's say US East, you select something which is closest to you. Asia Pacific, Australia, Southeast Asia. Let's see if there's anything else. And Middle East, Asia Pacific, let's say South India. Okay, we're probably close to South India. No infrastructure redundancy required. There are various kinds of things. We'll see what is VM scale set, availability set, but for now we'll say no infrastructure required. Security type standard, okay, standard. So again, if you need some additional security, we can go with this, but most of the time, I think the standard should be good enough. Then we'll use, for today, we'll build a Windows Server 2016 data center. You can also see all images, we can also configure, but we'll not go that. Azure Spot instance, you can click on this. Offers unused Azure capacity at a discounted rate versus pay as you go. Workload should be tolerant to infrastructure loss. In other words, Spot instance is much more. We are able to get much more cheaper servers and things like that when there's a lot of demand. Or in other words, if what we're doing is something not very highly critical, we can use these Spot instances. I think I can check that, but for now, I will leave that there. And let's say the size right now, if you click, on this drop-down notice recommended by image publisher. This is $173 per month. It has 2 CPUs and 8 GB RAM. And here is $94, much more cheaper. We can also click on see all sizes and give it a moment. Let's see what I have. Okay. These are the different kinds of sizes you can, ideally, we can select based on what we need and things like that. For you guys, you can just select the minimal things, guys, which is what I'll show you. There is monthly, and here's the cost per month. You can probably choose what is this one, general purpose. So notice this one, 13.94 per month. That's a very, very cheap one. We get only 1 CPU and 1 GB RAM. That is very, very low. 2 data disks, IOPS, temporary storage, premium disk supported. Okay, is okay. But the slightly higher one, 2 CPUs and 4 GB RAM. Okay, that's reasonable. But what we'll do, we'll just leave it the standard. This is 173, 8 GB RAM. Okay, what we'll do, we'll select, let's see if it'll allow me. Okay, let's see. Okay, here I'm just showing you this one. I'll not create this one. Then administrator account. Here we can give whatever name, username and password. There is some. The passwords, usernames, how they have to be. Generally for any website, they will give you some hints and things like that. We give username and password. Probably today, I'm not sure if I'll create anything, but I'll just leave it here. This is for a moment, guys. Okay. Now, let's see, come back here. This is lab. Bring this up. Okay. So now let's see, come back here. Now take a look at this one. This is the search. Here is a, let's say, portal settings, directories, and things like that. And then here is a slightly important thing, which is notifications, more events in the activity log, no new notifications from this session. So we can configure different kinds of notifications here. More events in the activity log, unsaved change. Okay, let's do a cancel. We don't need to look at it right now. Here is again the settings. And let's say that is the feedback and things like that. Okay, so we'll come back to notifications. There it is. Don't need any notifications. This is what it is. Now, let's say manageable item that can be created in Azure. Okay. Stop the share. Share it again. Okay. So what are the labs, what are the resources that we can create? Well, they can be app services. App services is nothing but different kinds of web applications or services where we will put a web service, different kinds of applications on this service that is a web. Then the virtual machine. Virtual machine is acting like a machine on another machine. That is what is virtual machine. In a single machine, physical machine, we can have multiple virtual machines. A single machine, single server is like a first floor. In that first floor, there are a lot of rooms. In that room, you can run 1 business or 2 or 3 businesses. That is virtual machine. NSG is nothing but network security groups. We will create different kinds of groups for different kinds of resources, and we'll see why that is required. Then we have the disk. For some virtual machines, we need more memory, more RAM, more hard disks and things like that. Then the databases. What are these? These are generally referred to the resources. We will try to rent these resources from the cloud service provider. The hardware, the software. Hardware is nothing but the infrastructure. This is part of this software. The SQL is part of the software. Okay. Then let's say, come here. Resource groups. They are nothing but they're groups of resources. Container to hold related resources is a group of resources is called resource group. If you want to manage the life cycle of resources in a resource group. In other words, we can create a group of resources and we can kind of manage the life cycle. We want to turn them on at one time, turn them off at one time. We want a certain kind of setting to be constant whenever we are creating a certain virtual machine. That is what is a resource group is, guys. Okay. Then let's see, come back here. Here's all resources, resource group. And let's say I'm going to create a resource group here. That also, I think, gives some issue here. As you know. All resources, and then we are creating a virtual machine. Okay. So I come back here. Back to virtual machine. So what we did was, if you, at the time of creating, we just created standard all size. Let's scroll up here. Here is where we created resource groups. Let's say let's review and create. Allow selected ports. Generally, we'll give an RDP and HTTP. That also we'll talk in the coming up days. But let's say what I'm wondering is, one more time I'll stop with this. Let me check my messages here. Still waiting. Okay. Back to the resources. Back to here. Oops. Resources. Virtual network. Okay. So this is where we're creating a virtual machine. Okay, this one should help us in creating a virtual machine. Let's give it a try. Let me complete this one then before we create it. So we'll increase the complexity a little bit and try to understand one more topic, and then we'll try to create the virtual machine and try to delete it also, so that you don't have to pay. So another thing which we need to keep in mind is virtual network. What is network? Network is networking, guys. In an IT company, when there are multiple developers or IT admins or other kinds of software or other kinds of employees, all their servers are connected. How are they connected? They're connected using networking. What is that? That is physical networking. But the cloud service provider, because everything is on the cloud, we are going to be we're going to be making use of the network on the cloud, which is much more faster, which is super faster. In other words, much more faster is what it is, to be more precise. And what is it? That is a cloud. It looks like the network is our network, but it is not a network, not our network. It's the cloud's network. That's why we call that as a virtual network. The networking is on the cloud. Allows you to define your own network in Azure. For each department, maybe you want to create a different network. Group of computers, they're all connected. They're only available and accessible to a few people. So you create a separate network. Virtual machines are hosted. So every time we'll be working with a virtual machine. We want virtual machines to be connected to certain networks where they have access to certain servers and data. We can define multiple networks. We can define multiple. We can create multiple networks and multiple subnets. Subnets is nothing but a part of a network, is what it is. So the entire building will have one network. In that entire building, there are many businesses. For each business, there is a separate network. Those are like subnets, as simple as that. Subnet is also a network. It's just a part of the bigger network, is what it is. So here is our own network. Each virtual network needs to be assigned an address space. So in other words, how are the networks identified and things like that? By an address space, by an IP address. Example of an address. Okay. Then what is happening? We define multiple subnets in a virtual network. We can define multiple subnetworks based on the IP address. Each subnet has an address space that is a subset of the address space of a virtual. So here 10.0.1, 0.2. These are two different subnets. Each subnet is also a network. A network is again a group of logically related laptops and things like that, guys. Okay. So now what can we do? Well, once our network is defined, we can then sign up virtual machines in the subnet. Again, what happens ideally is, in the real world, the virtual machines. Let's say subnet 1 is our coffee shop, subnet 2 is our restaurant shop. We want certain data to be available in coffee and certain data to be available in restaurant. Sometimes we don't want we want the data to be available in both of them. Sometimes we don't want them. So what do? You create a subnet in that one in a parent network, guys. Okay. So each machine launched in the subnet will get a private IP. We have something called each subnet. Subnet means in a subnet, there can be again a group of servers. So for us, a servers inside a server, we can create one virtual machine. We can also create multiple virtual machines. So what that means is a server is like a first floor. Inside a first floor, there are multiple rooms. If we want, and inside a room, what can we do? We can run one business or multiple businesses. Each business is one network, or each business is one subnetwork. If one room has two businesses, a coffee and a restaurant, so that room is a parent network, and the parent network of the room is the building network. The coffee is the subnetwork of the room, and the restaurant is the subnetwork of that room. They will have private IP. The private IP is used for communicating. If we need to make the two machines or the servers or the virtual machines communicate within the room, we will use private IP. If we want to connect it from the internet, then we will use a public IP. So every machine, every virtual machine will have private IP and a public IP. And if we want multiple rooms, we are running two businesses. One is on the ground floor, another one is on the first floor. We want to be able to access that network. Then what is that? That is called network peering. You peer. You're talking to them. You're making friendship and all. That is called virtual network peering. It's where multiple networks are also talking together. What are these things? All these things are possible with a few set of configurations and things like that. These are the things that we generally manually do. Networking department manually takes care of. Okay, so infrastructure as a service, we don't have to manage the underlying physical servers. We have discussed about the infrastructure. You don't take care of any infrastructure. You don't need a networking department. Deploy any type of work. You can do any type of work, whether it's a coffee or a restaurant or maybe any other thing also. Virtual machine gets deployed to a virtual network. So network is where you have a group of servers. A server can have one or many multiple machines. The virtual network consists of one or more subnets. Subnets is subnetworks again. So everything is a group of the parent. The parent is a group of has a group of children. When you create a virtual machine, the wizard will give you an option to create the virtual network. Okay, we will see that the virtual machine gets assigned a network interface. So in other words, it's like every time we create a virtual machine, in the moment we'll try to create a virtual machine. What is happening is it's like there's a network interface. It's like there's a physical resource which is getting associated. The network interface gets assigned a private IP. So internally, the private IP is given to it. You can also allocate, if you want that virtual machine to be available on the net, then we can also give a public IP. The virtual machine can have multiple disks. As I said, sometimes small amount of data is not enough. We need more amount of data for certain applications. So what do? You need more disks. Those are nothing but referred as VHD files. By default, you get an OS disk assigned to the machine. Okay, so in other words, every time we create a virtual machine, there's a RAM, there's a disk which we are getting. You can assign disks to the machine as well. You can assign additional disks to the machine. The OS disk is where the operating system is. Apart from that, we have drives where we try to separate the data and store it. That is what is called a data disk. Okay, we can stop virtual machines whenever you don't want. So let's say we want to run our coffee store or coffee shop only for 4 hours a day. What do? You just pay for 4 hours and go away. You can stop your business and then again start tomorrow. You can also control the traffic flow. How many are, let's say yours is a very premium business. You're doing a gold business and you don't want hundreds of customers coming in. You want only 10 customers, the first 10 customers. What are you doing? You're controlling the traffic. Now that's when the network security group will give us an option configurations. And you can also monitor the CPU utilization network. If there is too much of traffic coming, if there is too less of traffic coming, what we want to do is we want to either increase the business, or if there are hundreds and hundreds of customers coming in suddenly, we want to increase our coffee shop from one floor to maybe 10 shops, 10 floors. And I want to do it dynamically. And I want to do it only for limited amount of time. So tomorrow, there is going to be a cricket match. Lots of customers are going to come. So I want 10 rooms. I want 10 floors, 10 rooms. What do? Only on that day you will reserve it. You're expanding. That is called elasticity. So why? Because there is going to be a lot of utilization of resources. You need more people working. All that is being provided by the cloud guys. Okay, that is possible, is what it is. So now we'll see. I want to stop the share one more time. Let me bring up and see back to virtual machine. Before that, let me see. Still waiting. And so there's the virtual machine resources. I'm going to create D2V, the server to TS1V2, B2S. Okay, bring this up. I share this one. Share this one and create a virtual machine. Share this one. Okay. So here, this is pretty straightforward, guys. For you, for us, for today, I will just use this one and see how far I can go. I just created a new, click on create, just gave it a new temporary name. You can also create a resource group from another place. Then you can leave for most of them standard. We'll try to create a Windows server, DS2, see all sizes 2, and what did I create here? 2, we see 4 GB RAM, let's say. See all sizes. So here's the 2 and 4 GB B2S. I'll select this one. B2S, select. B2S 4 GB RAM, 51.39. Okay, let's say I've enter. Pardon me, here is root, admin. And password, you can give whatever you like, root. Come here. Cool. Allow selected ports. Okay, public. So if you say none, you cannot do anything. Generally, we do this one. Then we select RDP and then click on next. Then here we can leave the SSD. Premium SSD is for very slightly expensive. It is premium as the name suggests. So generally, what we can do, SSD is much more powerful, much more speed, much more faster. What we'll do is we'll select a standard HDD, default encryption. Yeah, we can just leave them the defaults. Then we can go on. Next is networking. Here, I think we can leave almost the defaults here. RG1 VNet, filter virtual networks. Okay, we can create a virtual network here, but we'll leave the default. This is what is default subnet, subnetwork, public IP, okay. And here is the info. Uses public IP if you want to communicate the virtual machine from the outside the network. Well, I don't think we need it right now, but we'll say, okay, we'll leave it as the default. NIC security network group. A security group contains security rules that allow or deny inbound network traffic. Whether we can connect from outside or inside is what this is about. Security group. And allow selected ports, we'll leave the defaults here. For now, we'll not worry about this specialized settings. We don't need to. Enable basic plan for free. This will apply to every VM in the selected subscription. I think these also enable with storage, enable with custom storage. We can disable, okay, we'll leave them. I will not worry. Enable auto shutdown. Backup, okay. Let's say go to the next one. Advanced, I don't think we need to touch anything. Next one is tags. Tags are generally used for certain departments. Let's say I give something like name is this sign. Say here is a HR department. HR department. 12 selected resources. That is just for tracking and things like that for reporting purposes. Then review and create is the last step. Validation failed. Required information is missing or not valid. So somewhere I miss the required information. Okay, we can download a template there. So let's say go to previous. So somewhere it should give us a red color. This image does not support login with Azure AD management. I didn't touch it. This will allow IP address to access. Yes, we need the access to the virtual machine. Place this version behind existing load balance not required. So something is basics. I think it's showing red color here. So everything in star is required here, and root admin. Oh, there you go. It needs a combination of alphanumeric. I did not give that. So give whatever you like. Oops. One more time. Let's say review and create. Take here. So we're going to be charged that much, $0.07. You have set the RTP. Let's give it a moment. So let's see what is happening. It's creating virtual machine now. There's also pricing available for others. Okay, we're about to create. It's a pay as you go. It's only as much based on how much I use and things like that. And all these settings are given here. HR department, this is just for our tracking and things like that. You can give anything. Let's say create, let's see. It says initializing deployment. Submitting the deployment, let's say save it. Deployment in progress, somewhere around 4 to 5 minutes it'll take, guys. So it's in progress. It's now creating a virtual machine. So before creating a virtual machine, what it's doing is it's allocating a server. On that server, it's installing Windows 2016. These, some of them should be already. So there it is, VM1. This is the virtual machine which we created. Cool. Oh, it's still in progress. Pay as you go. Resource group RG1. I have given some very straightforward names here. These are the other resources I may have created some time back earlier. Deployment details. Okay. So I guess still in progress. Start time. Stop this for one moment. I'm going to share this one. Now create VM. Say share this one. Give me one moment, guys. Okay, guys. So there it is. I think it roughly took about 4 minutes. So let's say go to the resource. We can create another one. Set up an auto shutdown, monitor it. These are the other things that we could do, but let's go to the resource. So it's in a pay as you go. And now, what is this one? This is a public IP, guys. Okay. So 52. So what we will do is, here's the other stuff, other kinds of things. We'll for monitoring. This is, since we just started, we wouldn't have much of CPU, disk, and things like that, and other things are there. But more importantly, we'll try to connect to this one. Let's say, copy this one. Then what we'll do is come back here. Let me see how I'm connecting from here. Oh, well, we have to download this one, right? Come back here. I can connect to a virtual machine. So let me come back here. So what we'll do is, let's say we can directly connect from here. We'll say RDP. Download the file. Say, open the file. So right now what we're doing is we're automatically connecting to this virtual machine. This Naveen, let's say more choices. This is a different account. So this is whatever we have given. Here we go. Say remember, click on OK. Say yes. There it is, guys. We're connecting. And if you give a moment, it will automatically bring up the server. So right now what we have done is, in a matter of few minutes, we created a server. And on that server, we have created a virtual machine. So in other words, there's a lot of expenses that we saved. We didn't have to buy the servers. We didn't have to have the expertise of the networking people and the networking department. The network and everything has been automatically created. If we want, we can increase and decrease the power of the server and things like that, guys. Okay, so it'll just take a moment here. Bring up some screens. So we are now logged into it. Start it. Okay, still coming up. And for a moment, let me click this. Are you able to see the remote RDP, guys? Are you seeing the remote RDP? Oh, you didn't see it. Oh, sorry about that. Okay, let me stop the share again. Say, come back here. Share it again. Say, share it. Share. Okay, so if we come back here, what I've done is, let me go here. Here we go. This is the remote RDP that I just remoted into the machine. This here. Say more. Hide the meeting controls. Okay. This is the IP address I just connected, guys. Okay. Well, one more time. Let me see. Close this one. So download the RDP. So go here. Double click that file. Root admin. It's going to ask me the password. Root admin. Say, click on OK. So there's the server, guys. It's getting connected. And now we can ideally install. whatever kind of software. Right now it comes with some basic software and things like that. And these are the things that we'll try to understand and so on, guys. Okay, everybody with me, guys? Quick yes, please. That's how simple as it as to create a server and a virtual machine is what it is about. Cool. So I come here. Okay. So in the coming up days, we'll go into more details, more possibilities and things like that. We'll try to explore and understand more. We'll try to prepare more and try to get these things much more at a simpler level and so on. Okay. For now, what I'm going to be doing is, I will also need to terminate. I'm going to close this one. Back to, so there it is, virtual machines. As you go model. So let's say I will go to all resources. So now notice there is VM1 and network watches South India is automatically created. Some of these things are automatically created and so on. Yes, okay. So ideally, what I would like to do is select that. See if it gives any options here. Delete it so that we're not charged and things like that, or the charge is minimal. Let me move my window and select resources VM1. Type yes, because I can keep it on till tomorrow. But if I keep it on, what will happen is we'll get charged, guys. Okay, even though it is not used much, whatever is the minimal charge, it will get added on. So I'm just gonna delete that one. Cool. Okay, I guess we can give it a few minutes and it will refresh automatically. Still working on it, still going on this virtual machine. Execute delete command on one selected succeeded. One succeeded, 0 failed, so it's should be gone. So VM1, IP, NSG, these are some of the other resources which got created as part of creating that one. As ideally, these things should be deleted. We can also configure and things like that, but those are slightly advanced administration stuff. We don't need to go so far. For this exam, Azure AZ900, we need to understand some of the basics and the fundamentals of this one. So that's what we'll try to focus and we'll try to get into some more details in the coming up days. Everybody with me, guys? Quick yes, please. Okay, for today, I'll stop it here, guys. We'll continue the journey from tomorrow. I'll start sharing some of these slides, the cloud computing slides in a day or two. Personal, some pig and hive. Okay. The pig and the hive. Okay, I didn't share. Okay, I will share that, Lavanya. Just give me a few minutes here. I need to work with our support team. And we'll continue our journey from tomorrow, guys. Okay. You guys take care, stay safe, and keep learning, guys. Okay. Signing off for today. Thank you and bye for now. Stay safe and keep learning. Thank you, guys. Bye now. Thank you.